friend.
Yeah, they don't know either.
It's a little late.
Well, I
in the
found
year
out
then.
why I didn't have any Miller moths. They were all in the,
What?
Judy, you muted yourself in the middle of your sentence.
I thought somebody else was talking. I found out why I didn't have any Miller moths. They were all in the first light in the kitchen. They came in and went into the light and died in there, and that's where they stayed.
Ew.
3 inches of Miller moths in the light.
Ew.
What'd you say, Zach? Have you seen them? Zach?
Oh, we were confused what like Miller moths were. We thought we were referencing something else, and then we're like, oh, they're actually moths. So
They're sort of inch long, and we've probably had 300 of them in our house over the summer. And Carolyn said, put a big bowl of water under a light, and told me to put
With
dish
soap.
soap in it. And, you know, for those of you who don't like killing Miller moths, we'll send them all to you. But
Well,
yeah,
they kill themselves that way.
yeah, they do.
Yeah.
Your hands are clean.
Suicide. Our cat likes
I
to
love
eat.
that. Yeah, go ahead.
Our cat likes to eat them.
He does.
Like the little wings are fluttering in her mouth and stuff. It's really
Oh, God, you know, I'm so tired of finding little wings all over the house, too.
yeah.
No.
We have 2 cats.
I think I've got 10 generations of them inside my shop vac.
Oh, yeah.
Ooh.
Jim, you know you can empty those.
Until it's full.
And they're fossilized. Layers and layers like geology.
fossilized moths.
Sedimentary moths.
Can you guys see the Skywatcher screen?
Yep.
Oh, okay. Well, we have a few photos to share before Bob tells us all about Venus. Shall we go?
And, just our next meeting, I'm not sure of the date yet. We're going to try again this month to get Leonard to, he's got 2 of his panel members for this UFO talk.
Yeah.
So we're going to try for that for in October, if not November, but at this point, probably about a month from now, if we can get all those people coordinated. But let's see, any other announcements we should? Oh, hey, tomorrow at 8:20, I think it is, the SpaceX is launching some more of their evil communication satellites. And if you want to watch the launch, spacex.com is where to go, or you can go to space.com. And you know, these are they shoot out about 60 of these, and it's a real space debris problem, but they claim they're going to give internet, I don't know if it's free, but to, you know, people in remote areas, remoter than us, and, you know, different countries. So yeah, it's fun to watch those launches. I think I've put, I don't know, John, on our website, do we have a link to where you can see where all the dates and the links are to the launches?
I don't know.
Well, maybe we'll do that.
Maybe we do.
You're busy, I know.
No, it's not that. It's more forgetful. I am busy, but forgetful. I spend all day
Yeah,
on.
if you want to,
Yeah, when you get to be your age, John, you know, it's a problem.
younger than all of us, most of us.
I'm still suffering from anesthesia 6 years ago. Oh,
You had open heart surgery, right?
yes.
Let's see. I have a pen. I do have a pen. Okay. Yeah, if you want to start, John, sounds good to me.
Well, since Judy and John sent me photos, I decided to put some of mine
Yeah,
in
it is.
too.
Is it a little low? Yeah.
We went down to West Cliff, down in southern Colorado, a couple weeks ago.
That's cool. Caboose.
Mm-hmm.
Nice.
And that one's not even a very good one. I should have chose a better one. This one's got some streaking in it from I left that shutter open too long.
Really dark.
But
Sky.
this is a iconic ranch on the highway down there. And we stopped. Center of the Milky Way had just set, but it was still pretty dang nice. Jupiter and Saturn are sitting there, nice and bright.
It's about 30-second exposure.
Yeah, 30 seconds. ISO was set at 12,600.
Wow.
So single frame.
One single frame. I have not of this, but of some other shots. I've got multiple frames. I need to stack them. I haven't done that yet. You're better at that than I am, John.
Oh, I don't know. I'll talk about that in a minute.
Beautiful.
Yeah.
There you go, John.
Well, that's a single frame also. So I was decided I needed to shoot a picture of the Milky Way also. This was Saturday, September 5th. But when I was coming back, my friend said, "Hey, look, there's something right next to the moon." And I didn't have the right lens or anything, so I waited to get home and then took out my 400 millimeter lens and got this shot. And by that time, the moon had already passed its closest point to Mars, but yeah, it still turned out okay.
Cool.
Pretty cool.
Thanks. So yeah, so this is my Milky Way shot. I was up at Lily Lake, which is right on Highway 7 in
Oh,
Mountain National Park. And you got the Denver glow, unfortunately, to the left side there. But it was a 24 millimeter lens, and I shot, I guess it was 8 exposures on the sky and 3 on the foreground, and stacked them all to get this.
Cool.
nice.
Oh, thanks. And there's the smoke from the Cameron Peak fire was blowing in occasionally, and I had to wait a few minutes to, but it was so close and so at such a low altitude that it would kind of blow in for a minute, then blow out, and it was really thick just to the north though.
In the wind.
Yeah, it was just a breeze down at the surface, but it was blowing through. And it was kind of cool getting up there. And, pardon? Yeah, it was pretty cool getting out for a change, and it only took about an hour and 15 minutes to get up there. So yeah, I was gonna say I tend to stack them up and try to pull a little more signal to noise out, and that was at ISO 1600 at f2.8. So that's what I have this time.
The reflections are really interesting, John.
Oh, thank you.
They are sharp for the mountains, but when you stack the foreground image, then the stars move in the reflection. And it's kind of interesting to look where Jupiter is in the reflection relative to Jupiter in the sky. Obviously, you couldn't take both the foreground and the background at the same time, though you were at the same location.
I was actually thinking about taking all my stacked images of the sky and taking the lake part of that and trying to layer that in, but it didn't work too well. So I ended up using just the stills with the drive turned off of the foreground, and it turned out okay. I had a couple double images of the really bright stuff, and I kind of, as they say, cloned them out just to make it look better. And I didn't have to go, I only had to do a couple of them, so it was only like a few minutes of effort on that part.
But I like this because they're all taken from the same place with the same setup.
Oh yeah.
It's not, every part of the image was something you saw.
Yes, yes.
Right.
A little more authentic that way. I think there's a lot of competition out there for this kind of image these days. I'm on a Facebook group called Colorado Sky, and just about every other day you get a really awesome Milky Way shot on there. I think, John, you're probably on there too.
I don't know if I'm on that one. I'm on Milky Way Chasers.
Oh, that's one also?
Yeah, and that one is to get anything published in it or to get shared, it's really stringent. They ask for, you have to have all the details, everything. And if you leave one thing out, I can't. But there's some stunning
I'll try next
photography.
year.
Milky
Try
Way
and
Chasers is that one.
Learn how to use it still.
Wow. And is that a public Facebook group, or do you have to
have
ask
to-
about getting on it?
Yeah, all you have to do is ask to get on it and they'll put you on it.
Okay.
Is it Colorado? What did you say it was? Colorado Skies?
The one I'm on is Colorado Skies.
I'll check it out. I may be on it. I don't do Facebook very often. All right.
Well, that's all I have.
Judy.
Yeah, that was, well, we were on the Zoom meeting on the, anyway, I just noticed out the window that there was this moon and in between the clouds coming in. So half of it is, the top half is kind of cloudy, but the craters were still clear. That was handheld at, I don't know, 200 or something, 200 ISO.
Those are clouds around it?
Those are clouds on the top.
I like his face. His cute eyes and his little nose. That's a good one.
Uh-huh. Now I can't unsee it.
This weekend?
And that was Thursday afternoon. And a little bit of, that was just a turn around and take it. Absolutely no thought to that one. So I don't know. Probably could have got the moon bigger if I'd used a little more telephoto or something. I don't know.
So those two shots that Judy took, we posted those on the International Observe the Moon Night last night. And there are 3,000 either groups or people around the world who are on that website. And we mentioned that we're Coal Creek Canyon Skywatchers. And if you want to go see a lot of shots of the moon and hear about some of these other groups, you can go to that website. It was in the email that I sent out Thursday, that John sent out Thursday, the link to it. It's actually a NASA site, so it's Observe the Moon.
That's all we got.
Well, if you go back about 36 hours, she sent it, and it's in the bottom half of it after she put some stuff on, and then you go down and down. There's a picture of Venus, and you go down and down and down and down. It's at the bottom of that.
Barb, do you want to introduce our speaker? Or does he need any introduction?
Oh, does he need introduction?
Please, let's just-
Some of you have heard him once or twice before, Bob Grimm, Dr. Bob Grimm. He's a program manager in the sciences, right, Bob? That's what it says on your website for
Assistant Program
Southwest
Director in
Research.
Planetary Science.
Yeah, Planetary Science, Southwest Research Institute in Boulder is who he's associated with. And he's, as you probably saw, a 23-year resident of Coal Creek Canyon, or is it, yeah.
Somewhere in there.
And he's been one of our members since, I don't know, almost the beginning, I think. And he's given several other talks, one on water on Mars. And then Bob, I think you did one on the icy outer planets. I think it was focused on one of them, or the icy outer moons of the
Yeah,
outer
like
planets.
Europa. Yeah.
Europa. And then 2 years ago, he did a talk for us about Venus and said it was the forgotten planet. And now it's no longer forgotten because people are, you know, as most of you have probably heard, it was in the news. I think the first day was about 2 weeks ago, Bob, I think. Yeah. And that they discovered the possibility of a life form in the upper atmosphere of Venus. And I've been up really late some nights, so after I heard that, I was looking at Venus and just going, maybe they're looking at us. If they have eyes, they're probably, well, he'll tell us all about it. Anything else you want to include, Bob?
No, you know, I mean, you have been asking me for some time if there was something that I could talk about, and I kept saying no. I talked about everything I knew about,
I wanted to watch it, damn it.
and even things I didn't know about. So yeah, when this announcement came out, I said, well, this would be a good opportunity just to kind of review what we know about Venus as well as the new discovery. So about half of this talk is recycled from a year and a half ago, but I spent, you know, the afternoon kind of trying to gather all the new stuff together. So, you know, this first slide is my slide from last time. You know, why are we interested in Venus? Because it's supposed to be Earth's twin, but it turned out very differently. You put two pies in the oven and they come out differently. Why does that happen? And then in recent years, trying to understand how Venus evolves is important to understanding with all these exoplanets that are being discovered. When you see something that's the size of Earth, when does that mean it's actually like Earth? So, you know, that's a great story for Venus. And it was also the first planet explored by spacecraft. But since 1994, the United States has not sent a mission to Venus. There's only been 2 international missions to Venus in that time. So Venus basically fell off the radar. And the point of my last talk was, well, gee, what do we do about this? And shouldn't Venus get some love? And is looking for life the only thing that we should be doing in terms of space exploration? And apparently the answer is yes, because now that this new discovery was made with this molecule phosphine, Venus is all the rage. So let's sort of start from the basics and get up to how this happened. This is a slide I showed you last time, a little background. When I was young, I loved space and I loved dinosaurs. And I ended up wanting to do space. So I got an undergraduate degree in geology and physics, and probably the breakthrough moment for me as like a sophomore or a junior was when I read a paper by this guy, Roger Phillips, about using gravity to measure the interior properties of a planet and how the giant Tharsis province on Mars might have evolved. I thought, well, that's what I want to do. At that same time also, I started to understand what little we knew in the 1980s about Venus, but that they were very different. So I got my PhD working on Venus and asteroids. I went to work for Roger as a postdoc, and this picture was taken probably around 1990 at one of the Lunar Planetary Science conferences. So this is Roger, he's retired. This is Sue Makar. She went to JPL right out of grad school and is now leading the Veritas mission. She's been the PI of the 3 attempts now to get this radar mapper around Venus funded. She's in the running again now. This is Robbie Herrick. He's in Alaska now. He led a smallsat mission concept in a year and a half ago, 2 years ago, that would have got picked if we got in our launch vehicle, but that didn't get turned, that got turned down. And that's me only pretending to eat the hot pepper. I worked a lot on Venus in the 80s and 90s. Since then, I haven't done much kind of original Venus-specific work, but I've been very interested in more ways of probing the inside of a planet from the outside. So I've been working on that for some time. There's an instrument I'd like to fly on a balloon to Venus that would be able to look on its inside. I've written lots of proposals for Venus, and I was the chairman of NASA's Venus Exploration Analysis Group, 2016 to 2018. And I will share with you that when this idea of life in the clouds first came up, I think the actual words that came out of me were, "We're going to endorse this over my dead body." So that's where we are now. So what I'd like to cover this evening is a brief review of Venus in general. We sort of went over a lot of this last time, and then I'll get into the phosphine and talk about what this means next. So you're probably all aware that Venus is the brightest thing in the sky. It's never very far from the sun because it's an inferior planet, closer to the sun than the Earth. It shows phases, and that these phases were very important in proving Copernicus's heliocentric theory hundreds of years ago now. In the mid-1700s, Mikhail Lomonosov saw that Venus was fuzzy and actually, did some geometric calculations to show how the rays of the sun would be refracted through the sun, and that was the discovery of the atmosphere. As we went through the last couple hundred years, this idea of Venus as a jungle evolved, and this goes back to Arrhenius, the same guy who also estimated a greenhouse for the Earth. If you may remember that when Jeffrey Bennett gave us a talk some time ago, he mentioned Arrhenius and his calculations for the effect of greenhouses and how he was pretty well on 100 years ago. So it was known that Venus was hot, but they didn't know exactly how hot it was. That had to wait until close to the middle of the last century, when radio telescopes detected that the surface, or that some part of Venus, the disk of Venus, was very hot. And it wasn't known at the time whether that was actually coming from the surface, or was it sort of what I would consider a pseudo temperature of the ionosphere. This is how Carl Sagan also got his start in talking about the runaway greenhouse for Venus, how once you started building up carbon dioxide, you would continue to trap solar radiation and the heat would continue to rise. So it was known then that Venus was hot and dry, kind of at the beginning of the space age, but there needed to be a high resolution observation to really separate these two ideas. And that happened with Mariner 2, which was the very first successful interplanetary mission. It had an instrument on it that confirmed that the high temperature was indeed from the surface. And in follow-on missions, they were able to profile the atmosphere and understand that it was dominated by CO2. So, these very basic facts about Venus came about because of the beginning of United States space exploration in the 1960s. The 80s, though, was owned by the Soviet Union. As a matter of fact, you may have heard a quote in relation to the phosphine discovery that Russia has a mission they've been studying, and that after all, Venus is a Russian planet, so they should go there. They were, the Soviet Union was immensely successful with Venus because we beat them to the moon, and because they couldn't seem to get Mars right. This is where they put all their space exploration effort, and they had a series of flybys, atmospheric probes, culminating in these couple of landers that in maybe about a decade or so ago, they were independently reprocessed into these pictures you see at the bottom that show, a more natural view of the surface, including these, ridgeline out there, multiple ridgelines in the distance. The pressure, of course, is known to be 90 atmospheres and nearly 900 Fahrenheit. So these landers can last an hour or two, and even the next generation of landers that are considered long-lived really won't go more than a couple of hours, with the exception of a very small lander from Glenn Research Center that might be able to last quite a long time. But this is the state of the art of Venus landings was achieved in the 1980s. In terms of orbiter and probe spacecraft, the United States, its most comprehensive mission was called Pioneer Venus. That was 2 spacecraft. One was a orbiter that used radar to map the surface for the first time, and then there was a series of probes that got descent profiles at several different locations around the planet, and one of them even survived a short time on the surface. The Russians were also busy in orbiters with the Venera 15 and 16 spacecraft. These flew in the early 80s and provided the radar maps like the one you see on the left That's Maxwell Montes with Cleopatra Patera, the large sort of crater turned volcano on the top of it. But that was quickly eclipsed by Magellan, which had much better resolution and covered much more of the planet. And here you see the Magellan image of Cleopatra Patera. So Magellan is sort of our base map for Venus, even today, but you can't see anything smaller than a football field. That was the end of the United States Venus exploration up until, well, we'll see. But there's been 2 missions since then. The ESA, the European Space Agency, flew Venus Express Orbiter that ended its mission some years ago, and it did a lot of atmospheric mapping. And then the Japanese launched Akatsuki in 2010, which failed to get into orbit in 2015, or sorry, 2010 or 2011. Its main rocket blew up, but the spacecraft survived, and they managed to nudge it into orbit using just its little thrusters. It's in a hugely elliptical orbit, but it's delivered a lot of science. So these have been good missions, but they were, they're not, they weren't huge missions. They were atmosphere focused, and they've been great. It's outside of what my expertise is, but the thing that is clear to everybody is that they have, maintained engagement of a new generation of researchers throughout a time when there's been no U.S. missions. I don't know why I put this in there. Everybody knows what this stuff is. The basic, you can look this up anywhere. Basic properties of Venus. It's the closest planet to us. It's on the inner edge of the so-called habitable zone. It spins very slowly backwards, but it's almost the same size and mass of the Earth. So understanding why it turned out different is a key question. A couple of points about the atmosphere. It's huge. In order to generate 90 bars at the surface, 90 atmospheres, you have this massive atmosphere. You can see the cartoon that's got some real data on the right. The cloud tops start at 60 or 70 kilometers and go down to about 50 kilometers. Those are mostly sulfuric acid. Below that, the atmosphere starts to get clearer. So if you get below the clouds at some level, you could see the surface, but you can see that the temperature is rising very quickly until it's this unbearable 740 K, 800 plus Fahrenheit at the surface. Interestingly, right near the top of the clouds, you see the temperature is 200 and something Kelvin. So that's basically room temperature, maybe a little warm, and room pressure at the top of the cloud. So that's in fact where the Soviet Union flew 2 balloons in 1984. They lasted as long as their batteries lasted. They were tracked from the Earth. And this is not only the region that we could put balloons in the future, but is the region that would be where potential life could occur. Life could potentially occur. The other fascinating fact about the Venus atmosphere, the big ones, and there's all kinds of chemistry, is this superrotation where the cloud tops move at more than 200 miles an hour. And it's related to how Venus already spins slowly and how angular momentum transfers from the solid body of the planet to the atmosphere. So there's a whole huge study that only in recent years are people able to start modeling the superrotation. It was really hard to actually understand previously. The surface is what I've worked on the most. So we'll just do a quick tour there. This is one of those garish pictures you'll ever see, but basically the parts where you don't see much contrast at all are the volcanic plains. The bright wispy things are deformed zones. They're ridges that scatter the radar energy back. And then the black things are mostly pulverized zones around impact craters. Most of Venus is pretty bland. It's at least to what we can see so far. The surface is a volcanic plains. There's different units that have laid on top of each other that we can't quite figure out the order that this happens. So you can see there's a kind of a darker unit and a lighter unit. And then on top of this, there was these ridge belts formed. So superficially, straightforward looking, but complicated in detail about how the plains of Venus evolved. More interesting to look at are these so-called tessera. These are, I think it's Latin for tile. They were named by the Russians when they first saw them. So it's interlocking deformation belt. So this whole region has been squeezed very hard somehow. And the only way that we know how to squeeze something on the Earth, because you don't see this on other planets, is with a large sideways movement of the crust. And that happens on Earth because of plate tectonics. So these are probably also the oldest parts of Venus, and they might be Venus's analog of a continent, something that was built up and squeezed a long time ago. And then the other interesting sort of major terrain type on Venus, I'm lumping these all together, rifts, coronae, and volcanoes. This is a big volcano, Ozomon's and Matmons. These are all a bunch of places where the crust is spreading apart, probably not as much. We know it's not as much as plate tectonics does on the Earth, but it's still stretching and breaking. And then these round things are called the corona. There's some kind of bubble or upwelling of hot rock that deforms the surface. So, these are evidence of activity on Venus. The main thing we don't understand about Venus in terms of how its surface evolved is because of the craters. Here's an impact crater right there. There's a crater, there's a crater, there's a crater, there's a crater, there's a crater. There's about 1,000 craters on Venus. By counting the number of craters and comparing it to the expected rate of formation in the craters, you make an estimate of the surface age. And that's somewhere in the region of 500 million years for Venus. So that's about the same as the average age of the Earth. The Earth is divided into very young parts, the seafloor, and very old parts, the continents. So it may not be a fair comparison, but on average, Venus has been active. The question is, because these craters seem largely untouched, one idea that came out early was Venus was very active, and then there's or it may have been active and stopped all at once, or it may go through bursts of activity. That the last major activity was 500 million years ago, and Venus is less active today, not inactive, but less active. The other idea is that the geology is not random. These craters are randomly distributed. It looks like it's all one surface as far as the craters can tell, but the geology is not random. So maybe there's something to the scale of geology that allows deformation in craters to be consumed on a small scale that doesn't affect the big pattern. So Venus could be completely active, just on a smaller scale. It would be like microplates instead of major plates like the Earth has. So here's a history of Venus, not necessarily the history, just one that that is at least kind of consistent. So the first principal idea is that because Venus is closer to the sun, it either never could keep water at the surface because it was just too hot the whole time, end of story, no water, or it could hold on to the water and it lost it. Now, it used to be that everybody thought, well, Venus got too hot. It was still 4 billion years ago, which maybe there was some early rocks formed and maybe something could become alive, but it all died, and it'd be like Mars. If we ever could get there, we'd be looking for fossils at the surface. But there was a paper a couple years ago by a guy named Mike Way. He's a climatologist, a meteorologist, and they did a model of Venus where it's key that Venus spins slowly. So they just put a bunch of water on Venus. They said, suppose it has an ocean, and we know Venus is spinning slowly, and in their model they watch the water evaporate and make clouds, and the clouds are always forming on the day side, but Venus rotates so slowly that the clouds don't get just whisked around to the nighttime. They just stay on the day, and the planet rotates underneath it, and that means that these clouds could shield the planet and keep it cool. And this is their temperature map, and some of these temperatures are below freezing, so it could be snowing on Venus. As long as there's no massive greenhouse atmosphere, CO2 atmosphere like there is today. So in my opinion, this paper was widely misreported in the press and misunderstood by scientists because people are just saying, oh, well, Venus could have had water until whatever this big catastrophe 500 million years ago. But the thing that has to happen that's not in this model is an entire geological cycle that somehow keeps scrubbing carbon dioxide out of the atmosphere so it doesn't build up. So yes, Venus could have had water until within 1 billion years ago. It depends on what the geological history of the planet is, which is linked to the atmosphere, which is linked to the geology. And the idea then is that once whatever happens, that you can't stuff the CO2 back in the inside or make limestone out of it like you do on the Earth, that the plate tectonic pattern of recycling would stop, and everything, it would either break up into these little microplates that we can't see today that aren't as efficient apparently, or Venus goes through these global recyclings every maybe 500 million years or billion years. So something changed at some point, and the atmosphere that we have today has built up from volcanic outgassing. Components of it, the sulfur dioxide has to be recycled in tens of millions of years. So it's coming and going somehow. But this massive atmosphere is at least hundreds of millions of years old, maybe billions. As we think about the implications of this potential life discovery, we got to think about this is the atmosphere that it has. It doesn't get any other atmosphere to work with. So the things that we've been talking about for Venus is a new radar mission that would have higher resolution of the surface, so we could piece together this global stratigraphy. This is from a mission I worked on where we showed this is a Hawaiian volcano that we degraded to the Magellan resolution and showed what the improvement would be with our radar. The mission that's in contention right now, I mentioned earlier, it's called Veritas. It's out of JPL, and it could be selected as early as this coming spring. The other main class of mission is a probe, and that could be a full-on lander like the Russians want to do. This is their Venera D lander, which is a more sophisticated version of the same design that they used going back to the early 70s. That's the way the Russians work. If it ain't broke, don't fix it. And the other part, and this would make actual surface measurements of the surface minerals, whereas this concept called Da Vinci, now Da Vinci Plus from Goddard, is focusing on sampling the atmosphere on the way down. So what's the modern measurements of the composition of the atmosphere? What's the atmosphere might actually record noble gases that would tell us about the building blocks of Venus. And then when we understand these things, we might understand more about how the atmosphere evolved over time. So this one you're going to keep in mind, obviously, as well. If it's going to make atmospheric measurements, can it tell us something about this new chemical? So here is close to the slide that I had last year. And this was the status of trying to explore Venus as of September 13th of this month. That there had been 20 successful missions to Venus, but that since the 1990s, when the United States stopped, there's been United States teams have proposed about 30 missions to NASA, and none have been selected. At this time, Veritas and Da Vinci Plus were actually in their first round of the proposal, and again, that's still coming down. Other ideas were all stalled. To get a huge mission to Venus requires this decadal survey, which is reconvening now every 10 years. To endorse this is like, hey, this is what we got to do. And they're not going to do that for Venus, so cross that off. There's ways with small satellites that we thought about. We lobbied the Associate Administrator for something called Venus Bridge, which would be smaller satellites. There's a small satellite program called Simplex that didn't pick anything for Venus. And these have been delayed for now. And then the Russians had this Venera D, which they've been talking about for years and having jointly sponsored symposia with the US, but nothing has happened with it until Now, this is what happened on September 14th. So this paper was published, phosphine gas in the cloud decks of Venus. And I only know one person on this list, Sarah Seeger. That's because, and even she is well known for her studies in exoplanets. So this all came about not because people were studying Venus, because they were studying exoplanets. So let's talk about what that means. So phosphine, you know, I'm reading the papers, which I partly understand. You know, I'm going to Wikipedia too, and I'm just getting it in one place for you here. So phosphine is produced by anaerobic bacteria. This is a highly reactive gas with oxygen. So they wanted to find a gas that would exist on a planet without oxygen. On Earth, it's produced by bacteria that function without oxygen. But they don't know, biologists still don't know how it's made, what exactly it does or how it's made. It's just observed. The exoplanet people got excited about this, and they published a paper earlier this year in a journal called Astrobiology, where they identified it as a potential biosignature gas for planets lacking oxygen. It has signatures both in microwave and in the infrared, and it's known to exist on, say, Jupiter and Saturn, where it's made at very high pressures deeper in the interior and is brought to the cloud tops where it can be observed. And these other papers, spent some time showing that it was very hard to make. I mean, they don't know how it's made biologically, but you can't make it abiologically either. And they said, well, really, you know, you can't really make this on either another Earth, or they were looking at super Earths, because there's been many of those detected as exoplanets, you know, planets with, say, 10 Earth masses. So they were really focused on this. And they decided to just look at Venus as a benchmark, because they didn't expect to see it, and they expected to find some detection limit, you know, well below a part per billion. And they would use that benchmark in their exoplanet studies. Instead, they found phosphine. So then everybody went crazy. I would call it a breathless rush, not only in the press, but there's a lot of talk about sending a mission to verify this. And we will talk about those missions. But in my mind, you know, the most important part of the scientific method, independent verification, hasn't really begun. And there are three parts to this. Is the observation reproducible? Can non-biological mechanisms really be ruled out? And, you know, even if we think we've ruled out non-biological mechanisms, what is the framework that we expect this to be happening on Venus, both for how things live in the clouds and what they eat, et cetera? So before I get into, you know, saying these bad things about it, I was very impressed by this paper. I mean, they sat on this for 3 years, 2 to 3 years. I mean, these observations were made in 2017, and to their credit, they kept it quiet. They worked very hard to try to rule out everything else. It's a really good piece of overall work. And now it's time for all the individual people who know one little thing better to go at and pick at it. That's the way it works. But I applaud this paper as a very thorough and well balanced. They don't say it's life. They say we can't figure out anything else, and we should keep working on it. The two things that come to mind that were like this in the past, in the 1990s, you may remember the Mars meteorite that was reported to contain microfossils and other indicators of life. And it was so exciting that President Clinton even delivered a press conference on it, part of which, if you paid attention, was edited for the movie Contact with Jodie Foster. So they redid his speech to make it sound like he was talking about discovery of extraterrestrial life or alien life, you know, intelligent life. But he was actually speaking about the possible discovery of fossil life on Mars. And the researchers said, well, you know, there's 3 independent lines of evidence, so we think that's why this is strong. It turned out that every one of those lines of evidence was weak in itself. And it took, you know, some years after that to straighten this out. Something that was more of a flash in the pan was cold fusion from the late 1980s, where basically in a chemistry experiment, some researchers claimed to have had a small amount of nuclear fusion take place. And people jumped on this and nobody could reproduce it. And there were flaws in the experimental technique, and it went away pretty fast. But you know, as time has gone on, from really no internet to speak of in 1989 to, you know, a pretty evolving internet in the 90s to now, you know, any kind of new scientific publication is distributed immediately to everybody. And again, to the credit of this group, they produced a pretty solid body to be attacked. So there's three parts of this that we can talk about. First is the detection of this chemical phosphine. This is in fact the farthest topic from my expertise. So I only know what I've read and what I've heard in gossip. There are two telescopes that they observed this with. Now these are radio telescopes because they're looking at radiation in the millimeter range, which is way too long wavelength for us to see. And so the groups looked at this from the James Clerk Maxwell Telescope in Hawaii and the ALMA Telescope in Chile. This one shows the data in black, and then this is the complete model, but they knocked it down some way. And so they're basically saying that this divot is the detection of the chemical. And even when there's other divots around, and they had to do a lot of fitting data processing to get this done, they lay it all out in the paper, so people know how to do this, can reproduce it. But this is the principal observation. The other observation actually got data resolved by latitude on Venus. So close to the North and South Pole, they didn't see it. Even in the mid latitudes, they didn't really see it. It really shows up to them quite near the equator. And they talk about this as being confined by the so-called Hadley cell circulation of Venus, but the Hadley cells go up to higher latitudes, so it's not a one-to-one match. But nonetheless, the idea that there could be some atmospheric circulation control on where this stuff is could be natural. It could be where the bugs can live, only near the equator. Nobody knows. But there's a certain community of people who are going to go right at this and try to verify the actual observation, and that's the hallmark of a cornerstone of what has to be done. I was particularly interested in this part, and I've got some experience in chemistry, so at least I could read what the arguments were. But they go down this list, and it was actually started in the companion paper for exoplanets earlier in the year. And they basically say that every one of these other things, chemical reactions in the higher temperature near the surface, chemical reactions from the sun, influence of the solar wind, lightning, meteors hitting the atmosphere, all those aren't just short, they're short by orders of magnitude. So this is an amazing claim, and that everybody who has an expertise in each of these individual things we'll look at. For example, I've looked at lightning on Venus, and I think that they have the wrong reference, and that there's a lot more lightning, but is it enough to make it up by orders of magnitude? That's the real question. The third question is, well, how the heck can anything live there anyway? The first issue is, it's the atmosphere. Yes, there's bugs that live in the atmosphere of the Earth, but to my understanding, they didn't evolve there, and they don't live there permanently. They're swept up from the ground, and they can survive there for some time, but we don't have an ecosystem in our atmosphere. And so not only does this ecosystem have to evolve in the atmosphere, but it has to avoid getting torched when some kind of downdraft sends everything down. Now, Sarah Seeger, in the same group of early companion papers, proposed this. Obviously, she was thinking about Venus early. Proposed a life cycle that involves, well, the bugs might get go as low as 40 kilometers, and they would just get dried out, turn into spores or something, and then they come back up, and I don't know where the water comes from, but they get water again. I haven't actually read this paper. I just looked at a cartoon. They come back up, and so there could, they'll expand the cycle beyond just the little bit where we know that the temperature is narrowly habitable by our definitions. The other big thing, though, is well, what are the bugs eating and what are they pooping? The amount of pH of this phosphine on Venus is orders of magnitude bigger than all the phosphine on Earth. Well, our biosphere is mostly, involves a lot of oxygen, so our phosphine gets destroyed quickly. But if there's 10 parts per billion of phosphine, and that's some kind of byproduct that these bugs make, what's the rest of the biochemistry? So here's one idea that was published in a paper by Sanjay Lamay, in which the bugs are basically using sulfur, very abundant there, and iron, which would eventually be coming up from the surface, in their metabolic cycle. And this is the Over My Dead Body paper, because Sanjay is very, longtime Venus researcher, very excited about this idea. He's an ultraviolet spectroscopist as well as a atmospheric guy, and he thinks that nobody has fully explained what the dark markings are on Venus in the ultraviolet, and he has said, well, they're dark because bacteria are absorbing the light. That happens with some bacteria on the Earth. So you may be looking at a picture here where all these dark things you see are vast swarms of bacteria in the atmosphere of Venus. That's the level of speculation where we're at. What is next? We have to do this work that I mentioned. There's a lot of press and exciting things going on. I think this is such an exciting topic that it will attract many people to look at it. And it may take a year or more, but let's see what it looks like. There was a press release that this company called this group called Breakthrough Initiatives immediately funded her and a small study team to look at the issue of life on Venus. But whether people have this kind of money or not, they'll look at it. I mentioned Da Vinci earlier. It's one of 5 missions that's on the table, but you would think that this would be an important tipping point for it. It's a descent probe. It makes chemical and isotopic measurements. I don't know exactly what the descent profile looks like and whether it senses this part of the atmosphere or whether their instruments can do it, but my guess is they can. You've probably also heard maybe of this Rocket Labs. Rocket Lab is a private company that has its own booster. So they're trying to get, business of sending small sats into low Earth orbit, the same kind of market that Elon Musk and SpaceX are going after that Barb disparaged because of its space debris issues. They want to do this too for communications, and they want to make a big splash with some kind of interplanetary mission. The only thing they mentioned was some kind of probes being deposited from a mothership. Both of these are very hard to do on a shoestring budget, tens of millions of dollars. But they certainly have captured interest. There's a NASA program called Simplex. I mentioned that earlier, that Robbie Herrick proposed for Venus, and I was on that mission. That has just been indefinitely delayed, but if they can restart this in a year or so, those missions could still make a 2026 ride-along launch with another spacecraft. So sometime in the next couple of years, we could be seeing missions that follow up on this in some way. So part of this, again, is my conclusion from last time, that I still like Venus because I think it's the cornerstone for understanding how Earth turned out the way it did compared to everything else. And NASA has not launched a mission to Venus since 1989, in spite of all these proposals. The number of people working on Venus has declined because, somebody proposes a mission to asteroids and they send that mission and it sends back some good science. And then younger people get interested in that and they write papers on it and they grow up to be PIs and they write their own proposals for asteroids. So nobody has done that for Venus. So it's been a negative feedback cycle. And so last time I ended on this sort of like, gee, let's get Venus going again. But this phosphine discovery hopefully has done that for us. Regardless of the outcome, I'm confident that it probably will precipitate one or more missions, and probably any mission that sends back enough data for more than the actual science team of that mission to work on. If it provides a legacy of any kind, a database that more graduate students can work on, for example, then that might kick this cycle back over to where we could start seeing more missions to Venus and understand what's really going on with our nearest neighbor. So that's my talk. Now we can all talk.
Bob, this is Clark. Could I ask you a question about the phosphine that I think you may have heard me ask in another context within the last couple of weeks, but this detection is at radio wavelengths, and I don't know much about it, but in the infrared, where I do know about it, nobody would detect some chemical composition or mineral or any other thing on the basis of one absorption line. Now, you mentioned that there were also complementary infrared observations of Venus, but I haven't seen those. But as you were studying up for the talk, is there more evidence besides this one single line? There have been many mistakes in past years and decades of people supposedly identifying that Saturn's rings were made of carbon dioxide when they actually are made of water. And could you comment on that?
Sure. Let's just put the screen on. Can you see that?
Yes.
So this is an infrared spectrum, and it shows where they think that the phosphine stands out the best. This is all done for exoplanets, and they need 90 hours of James Webb Space Telescope integration time to do this. 90. So that's where this all came from. So yeah, I think the signal to noise for Venus is just not there to do this, or else from the Earth where nobody's tried. I don't know. Your point is well taken about a single line, and if I'd remembered what you'd said during our previous discussion, I would have made a bullet of it. That is one of the things that they call for, I think, at the end of maybe right in the introduction of the paper, or somewhere along the line. They're saying, we need, there we go. Other pH3 spectral features should be sought. So, yeah, that's it right now.
Okay.
Bob, I know most people know a lot about exoplanets, but could you say a few words about it? Like how many have we detected now? And just in case there's anyone who doesn't know. Sure. Exoplanet, maybe
so starting in the 1990s, I guess, with new techniques that I won't go into, the discovery of extrasolar planets, exoplanets, started to tick up, and especially with the Kepler mission of a decade ago now, the number of planets orbiting other stars that is known is in the thousands now. I mean, I used to have an app, and I'd like look at the update and see how many new planets were found, and I deleted the app. I needed the space. There's so many. The characteristic of most of them, though, is that because of the observation techniques, they're mostly either very large, like bigger than Jupiter, or orbiting very close to their star, or both. So it's very hard to find an Earth-like exoplanet. A lot of the reasons because you need something that's got a favorable geometry, and you have to wait an entire orbital period of whatever that planet is, say it's a year, to get it. Whereas these other planets orbit their star in days often. So there's many known, thousands of known exoplanets. Almost all of them would be considered uninhabitable by us. The handful that are potentially habitable usually make the news. And the James Webb Space Telescope, if it ever launches, is an infrared telescope. That one of the things that people like these groups are starting to key up for is to show how they could use that to not just detect the planet, but to measure at least some aspect of the composition of its atmosphere, and just seeing a planet that has oxygen has long been considered a smoking gun for life. You just don't have planets with oxygen because it's so corrosive. But for chemical reasons I don't understand, that's not considered such a good argument anymore. And that's where this phosphine came from, is something that would be diagnostic of life. And so that's what they want to do when JWST launches. Where are we at? A year and a half still, 2 years from its launch?
Bob, I have a question. This is Carolyn. So
Carolyn.
if this is proven to be, or the suggestions get to be really strong that there's some sort of anaerobic life there, we're going to need to know something a little bit more about it, maybe based on what we know about how they produce it on Earth. How's that going to tweak the planetary protection protocols for any of these missions that are going?
Yeah, that's another question that starts coming up now. Yeah, it'll be interesting to see how seriously NASA takes it, because Da Vinci, if it's picked, it's only meeting a certain level of planetary protection, and I don't know if they can just sterilize the whole spacecraft like they did Viking, right? I mean, if NASA picks up the budget for it, they might be able to do it. I mean, you just put it in a big bag, and I forgot what chemical you soak it with, but so that's my guess, is that yes, it will trigger planetary protection, and somebody's got to come up with the money to pay for it for Da Vinci or whatever. I mean, the Venus proposals we always wrote, it's like, who gets stuck with the planetary protection section, because we have to write a page of why we don't care, and why NASA doesn't care, and why it's okay. And yeah, you've hit the nail on the head. That's going to completely change.
Yeah, it's kind of like having to write up the human research protocols, right?
But Bob, this is not a new idea. I mean, obviously, this is much more potent evidence, but the idea that there might be life in the clouds of Venus has been around for decades. And I sat on one planetary protection committee, and not one concerning with Venus, but I'd be surprised that there weren't previous considerations about that.
Maybe so. I mean, there's the David Grinspoon ideas, and
Right.
then there was Sanjay's paper, which said, oh, these could be bacteria, but there's still lots of other possibilities. This is the first paper that has comprehensively found something that they think is unique to life, and so I think it's going to elevate the considerations more than previously.
Yeah, probably.
Has there been any indication that they'll use this discovery to maybe look at Jupiter or Saturn for this kind of thing?
It exists on Jupiter and Saturn, but it's
I know, but in the clouds, not deep down.
No, it comes up to the clouds. That's how we know that it exists. So they see it on Jupiter, and they're like, oh, this can't be formed here. But the pressure and temperature increases so rapidly that this isn't coming like from the core of Jupiter. It's from a couple hundred kilometers down or something. So it just gets circulated up into the atmosphere where they could see it. So it could be a totally non-biological origin for Jupiter.
Sure.
Not that I wouldn't like to see floating gas bags on Jupiter.
Bob, can you say a few more words about planetary protection? I mean, obviously part of it is protecting the planet from our bugs and DNA and everything. But it's also like on the return sample missions, if there ever is one on Mars, protecting our planet, right? But maybe you can say a few
Well,
more
yeah,
words
thank you. No, I
about that.
kind of skipped over what that was. So actually, traditionally, I thought of it was the other way around, Barb. That I heard planetary protection. It's like, oh, we don't want the Andromeda strain coming back from their planet, so we can't have it, have it wipe out the Earth. But I was educated in the '90s that no, this is about not forward contaminating other planets. So whereas for more sample return, the back contamination is consideration. Sample return from Venus is very hard. It's conceivable you could skim through the atmosphere, and there was a proposal for that some years ago. And so you wouldn't be able to. I mean, if you kind of went into the atmosphere and float on a balloon, then you need and you float all around, did a bunch of sampling. Then you need a rocket to like blast you back up into space. Really hard. But it's conceivable that you could skim down to maybe 50 kilometers. No, they can't go that low. It's the homopause height on Venus is like 80 kilometers or something. So you can't skim through the atmosphere and get low enough to pick up the stuff. And then plus you'd probably just wipe it all out. So yeah, I would still say that any kind of sample return from Venus is still distant, and that by doing more probes and possibly balloons, or there's ideas for Venus airplanes, that we can do a lot of work in situ before we have to bring anything back.
Hey, can you comment on getting to Mercury? We got Pepe Colombo making 2 swing bys of Venus, one next month and then another next year. I try to dive into their instruments, and I'm not good at that. So can that offer any kind of insight in its flyby?
When I was chairman of VEXAG, we had an initiative called VGASO, Venus Gravity Assist Science Opportunities, where we tried to elevate the level of interest in Venus on Bepi Colombo and on the other Mercury mission. Oh no, Solar Orbiter and Solar Probe, and it was a pretty deafening thud of no interest. So I mean, I know that like Jörn Helbert has an infrared instrument on Bepi Colombo. He's a leader in trying to get infrared spectroscopy of Venus, and yeah, they maybe they made the observation, or so the flybys have not happened yet, have they?
No, it's coming up.
Okay, so
Next
yeah,
month.
doubtless he will make the observation. The question is, in a flyby, can he get the signal to noise? And his bands are also set already, right? His bands are set to look at the surface of Mercury. So he probably has nothing in this wavelength. When you want to fly an infrared mission to Venus, you pick certain bands that can see through to the surface, through the clouds in the infrared, and you pick other bands to understand the atmosphere. So off the top of my head, I would guess that he is not set up to do this. And I don't think there's any kind of microwave emission because there's, they're going to Mercury. There's no atmosphere to look at this kind of stuff.
And one other thing, I'm going to try to protect ALH. First of all, it's still arguable, and that's still a live but minutia of detail that I have no idea how to appreciate ALH now. But one thing that it did do is like what you're intimating, which is it kick-started return sample. I mean, it really had a provocative effect on NASA. So even if this, and again, if this phosphine thing disappears, you're right. I think the ripple effect is going to be still reverberating because of this finding. So it's still good news for Venus.
Bob, this is Kelly. May I ask a question?
I'm all ears.
Can you speak just lightly on the interaction of the sulfur cycle and the formation of phosphine and how they might come to coexist?
Sure, that's an easy one. I don't know.
You know,
Um,
Kelly, I think you did some research
yeah,
about
yeah.
Todd's talk.
Yeah, no, nobody, I mean, I have not delved into any literature about how phosphine is formed by anaerobic bacteria. There's a great quote by this woman, Susa Silva, who's the main sort of chemist and who wrote one of the papers here. And she said that phosphorus and hydrogen normally hate each other. Hydrogen has better things to do, and she's made it very anthropomorphic. It was very, it's in one of the press releases. But with enough energy, in a cell, for whatever reason, you can put phosphorus and hydrogen together. And I don't know why they want to do this and what part of the metabolic cycle it involves. Anaerobic bacteria often do involve sulfur, or iron. So it's conceivable that the whatever our bugs are doing that produces phosphine, Venus's bugs could be doing too.
Mm-hmm.
That is
Thank
just
you.
sheer speculation.
Sure.
Hydrogen has better things to do.
I'll find the quote. Yeah.
I like.
Thank you, Bob.
You're
So
welcome.
Bob, I have a question.
Shoot.
It's kind of complicated, but you're showing the night side of Venus in the last picture.
This one?
That's probably, is that near infrared?
That is it's a composite.
Yeah, and
It's actually ultraviolet infrared composite.
okay, because well, I guess the question is, you mentioned the fellow that has the paper that said maybe the ultraviolet absorption was due to biological, entities. Is there any correspondence to the ultraviolet cloud or the absorptive areas and the infrared absorptive areas?
So I think I misspoke there, John. This is two different infrared bands in a Kotsky superimposed.
Okay.
And this is
Ultraviolet, right?
Yeah. Now, so last year, let me see if I can just pull it up. Last year, I showed a bunch of pictures of Venus 2 years ago, and I labeled them what they were. I wish I knew what that file was. Okay, I'm not going to do this in real time. How do I get Word to take this and put it down there, including? All right, maybe it is there.
2014 Skywatchers?
No, no, it wasn't. It wasn't 2014.
2018.
No, Skywatchers 1. That's the one it is. Okay, so this is when it was the Forgotten Planet. And so yeah, we can see the whole Forgotten Planet again. There's the same talk, except in the middle, I stopped to show these swell pictures. So here's one. This is the ultraviolet. I don't know what wavelengths they're compositing, but in this one, the black stuff would be the swarms of bacteria. So they're kind of feathery, right? And there's much more detail in Kotsky. And then, yeah, this is also ultraviolet. I mean, this looks like the wind is pulling those out somehow. Another ultraviolet composite, a lot of structure. Yeah, so yeah, so the modeled clouds, those are basically cumulus clouds. But they would be some clouds full of bugs and some clouds that weren't. This is a cool one because it's infrared and you're seeing the glow coming from below. That one I showed somewhere else. Yep, that was it. So does looking at pictures answer your question, John?
I guess
Right.
we'd probably need to have pictures taken at the same time with the different wavelengths, right?
Yep.
It's interesting though. I mean, it'd be nice to see something that was done at the same time, you know, but
Yeah, I mean, I could see somebody proposing, I mean, I don't know what kind of integration it takes to get a good enough signal to noise in either the infrared or the ultraviolet. But you would think that if you had some kind of orbiter that was elliptical, and so when it's hanging out near the top of the orbit, you could take a lot of pictures.
yeah.
And you'd be close to Venus, so you'd have a lot better resolution. So somebody's going to propose that.
And then you need the mid-infrared camera that could maybe get that phosphine region that was shown in the
Exactly. Yeah,
mid-infrared
that's
there.
what I was talking about. Yeah.
Yeah.
Because if it takes, so they're talking about 90 hours for an exoplanet to get however many sigma signal to noise. So I don't know, scaling the size of JWST to some kind of space camera and looking at the, the photon efficiency and stuff is all going to be about the same, I guess. But yeah, I mean, how much time do you need? I don't know the answer to that, but you would think that being close to Venus would help a lot.
Yeah, I would.
Hey, Bob, this is Mark.
Hey, Mark.
So, hi. You might have mentioned it, but so phosphine, was it at like barely detectable concentrations or higher than that?
They considered it pretty robust because I'll just show the paper again. They are, again, as Clark points out, it's one band. But the idea is, so this may not have shown very, that's their error bar. So they're saying there's all this other stuff, and then at this one frequency, I guess they've isolated this frequency, and then we see this as the zero Doppler. Somehow they zoom in on that. So they pick this frequency and they say that it stands out with however many standard deviations from the rest of the stuff.
That the band is real is very likely to be true, although there is noise in the spectrum. The identification is a problem, but what I understand they interpret it as meaning is that there's a whole lot of this stuff in the atmosphere of Venus.
Right, 20 ppb. And
no. But in terms of the potential microorganisms and so on, they think they might dominate that dark material that you see in the
that's the link I'm trying to make, because I said, if there's only 20 ppb of this stuff, what's the rest of the biology like? Is almost all the sulfur and iron in the clouds, part of this massive biology? I mean, look at Mars. We've been arguing over 1 part per billion of methane for Mars for years, and people understand a possible, biochemical cycle on Mars that would produce methane. And we have a whole planet, smaller than Venus, but a whole planet to produce it, and they can't get it over a ppb. And yet here, Venus is producing 20 ppb of something that is entirely some kind of side product.
So in terms of half-life and atmospheric chemistry, does it have a short half-life and just keep reforming? I mean, we got the UV coming in and all that.
So they somewhere in here they discussed that. I think they expressed it as sort of a lifetime. So maybe that's several half-lives. I don't know how they quantified it, but it's probably years, and they come up with an upper limit of 1,000 years. So it has to be replaced somehow.
That's a long time.
It's short compared to 100 million years.
Yeah.
Bob, I just found a paper on the reaction between phosphines and sulfur dioxide.
Do you want to share it?
Sure, I don't have the paper here, but I'll tell you what the summary is here.
Oh, okay.
It says that the reactions between sulfur dioxide and phosphines containing pH bonds generally give rise to the most fully oxidized acid containing phosphorus that can be formed without cleaving the PC bonds. That's by Chan et al. Let's see here.
Sorry, I'm writing and you're getting a close up of my mouth.
I'm gonna
Put it in the
pop
chat.
this. I'm gonna pop this to you here. I just wrote
Okay.
it down in a chat email.
Good.
There you go.
Very nice. Yeah, I mean, this is going to turn into, you know, a lot of people are going to look at this, and it's very exciting.
You know who would be interesting to weigh in on this is Penny Boston.
I know Penny.
Yeah, of course you know Penny because you're bold, but I wonder, I would bet that she's run into these kinds of problems in some of her cave research.
Interesting.
Mm.
I'm just trying to find a place to paste what you just sent me. Nice.
If you're trying to capture something in chat, there's 3 little dots down in the lower right, and you can click on those and actually capture everything that's in the chat into a file. And that works out to be real handy.
That's better than copying and pasting, isn't it? Oh, I see
can
that.
also-
Okay.
I can also share the
Thanks,
chat
Jim.
with you after.
Here.
After.
Yeah.
Don, you're recording this, so maybe eventually we'll have it on our website.
I'm sorry, I couldn't hear you. You're too far away.
Yeah, we'd let's see. Okay, yeah, we'll probably have this posted on the website eventually, right? This talk.
Yeah, soon.
Yeah.
And then, but what I get when I recorded it is I get the video file. I also get a transcript of the whole thing, and I get the chat. So if it, you know, of all the chat activity, otherwise it doesn't get saved. But I get all.
It makes a transcript? A transcript?
Yeah.
Wow.
I don't know how it does it. And I have not looked to see how accurate it is.
You
I can
actually
share
have to
with
go in
you.
and change things once in a while because we used it for a meeting a couple of weeks ago, and there were some things that it doesn't recognize certain words, and so it'll try to substitute the next closest words.
It's any voice recognition, I guess. Yeah.
But yeah, but it's actually pretty good.
Do we have any questions from our young colleagues?
You have that one question. No. No, I think we're good. I mean, you did a great job presenting, and I read some articles on the on that find, and it was very interesting, but I did not know that much about it. So, I mean, we're learning about phosphate right now in chemistry. So it's like, but like we're not learning about like phosphine or like phosphate.
No, this is the exact opposite of phosphate.
Yeah.
It's like because phosphate, it's got oxygen in it, and phosphate is everywhere, and it's useful, and you can make it in the lab. Yeah, you'd probably kill yourselves making phosphine. Apparently it was in a Breaking Bad, the very first Breaking Bad episode, and when I looked it up, they said that what he did was bogus, but it sure made good TV.
No, but yeah, you did a great job. That was really interesting.
Well, thanks for tuning in, you guys.
Thanks.
Bob, one question I have is when you sort of chip away at some of the people that are talking about this finding, I always ask, okay, what next? You kind of got to that. But is there any kind of one instrument that would be, maybe it hasn't been flown yet, but maybe it's something that could be either in a balloon type experiment or on a orbiter? And is there any one kind of instrument that would be your recommendation?
Sure. And that's the danger, is looking for one instrument, right? You want multiple instruments.
Well, if it's a deep mission, you may not have,
yeah.
a lot of instruments.
So on a, I mean, I don't know what all those different spectral lines and stuff are, but an infrared camera, an infrared imager that from orbit would look at this exact wavelength that they've talked about in the exoplanet paper, but people have to work out whether it can actually detect anything at Venus. So presumably, they've identified the infrared, and so people are going to look at that, the infrared. When you go in situ, either from a probe or a balloon, I think a mass spectrometer has got to be part of this story, because a mass spectrometer would identify phosphine as a compound. And that's what I asked, does Da Vinci do this? I mean, presumably they have a mass spec, they have a big mass spec from Goddard. But I don't know, if any preparation is needed, or whether phosphine gets destroyed when it gets sucked into them, I don't know. But a direct chemical measurement, in the atmosphere would presumably go a long way. And you would, if you're worried about doing this on the descent, you would, better way would be to do it on a balloon, where you would be able to correlate the occurrence of phosphine with what kind of clouds you were in, and what latitude you were at, and what you were measuring. I mean, there's been, one of Sanjay LeMay's ideas is just take a microscope. Just take a microscope and put some of the drops on and see if anything's swimming in it.
Yeah. Yeah. How about, I think the other thing that's kind of interesting, and I just forgot what it was. It's so interesting. God, never mind.
It'll come back.
Oh, it's the two NASA missions now in the Discovery review process. Now, some people are kind of thinking that perhaps NASA could be bold and pick both of those missions. Would that be a good thing, or are they complementary? Are they? That would be a great.
It would. What I have heard is that NASA's, they're only going to pick one.
Yeah.
So they don't have money for two. But these missions have had a long history. The teams have been teamed together before. They've been apart before. There's the two missions are very complementary. All the excitement right now is on the in situ measurement of the chemistry, but understanding the global geology and how the surface and atmosphere interacted over time, and where did the atmosphere come from, how does it relate to the geological history of Venus? I mean, that would, those two missions together would mean that NASA would, could forget about Venus until 2050 this time.
Okay, thanks.
No, I mean, if it turned out to be really interesting, then you'd have a follow-on. But the scope of what we've really fought and hoped to try to fly are really just those two missions. And balloons would be great, long-lived landers would be great. There's a lot of things that could be done, but my philosophy was always something, anything, just to kickstart this process again. You're muted, Barb.
Okay. Yeah, Leonard wrote an article about this discovery, and he actually quoted Bob Grimm for Scientific American, and also did an interview that he just transcribed last night with David Grinspoon for space news. And I think on that one, he'd have to wait till it comes out, which it might shortly. But, you know, we haven't usually done this, but we could send you all that are on tonight an email with the links to those, or I guess we could put them in chat or something. And then maybe send you the link if we do that tonight to that launch tomorrow, and the website that has all the links to the launches, future launches, if you'd like that. That sound good? Okay, I see a few thumbs up. Okay. Yeah.
Yeah,
Does anyone?
I went on Scientific American and I couldn't find it, Leonard. So maybe
I sent it
not
to
in the
you.
payroll.
In the
You
last
did?
line.
He
Huh?
sent it to you.
I'll send it again. And they spelled your name right, so it's even better.
Okay.
I think the subtitle was The Grim Reaper.
Heard it before.
So yeah, anyone else have anything
Right.
here? I mean, we don't have to go away, but
Bob, you're
some of
a
us-
geologist, is that correct?
I'm a geophysicist.
Geophysicist. So this is off subject. You can ponder it. Why did they decide to pick Yucca Mountain in Nevada as a nuclear repository?
I know a lot about that.
You do?
Both from my company and from my wife.
Mm.
They picked it because nobody lived there.
Well,
And until so back in the day, the senators in Congress from Nevada were happy to take the federal money for the jobs that the repository would make, and it is actually volcanically active, and not a place that I would pick off the top of my head, but a lot of studies were done that showed that, you know, yes, volcanic eruptions have happened there, but the odds of one in the next tens of thousands of years or a million years, whatever, was low, and that, you know, we could put stuff there, and that it was pretty dry, right? But then the Democratic senators changed their mind and decided that it was more in line with national politics to reject Yucca Mountain, so it got shut down.
mm-hmm.
So the answer is we have no place to put our nuclear waste.
Great. Thank you.
Well, one of the interesting things there is that the scenarios for releasing the nuclear material would kill more people than the nuclear material that was released.
Oh, that's interesting. So you mean if like there'd have to be a giant nuclear war and it would blow up the mountain, but everybody would be dead from the nukes in the first place?
Or if it was a geological event.
Sure. Okay. A massive, yeah, like a Yellowstone type eruption.
Correct.
Yeah, I found this topic fascinating because my company had a group for a long time that was a federally funded group to do research on Yucca Mountain that the National Research, the Nuclear Regulatory Commission, other NRC, used as part of its oversight of the Department of Energy, who the plant would be licensed to. And, you know, so I got to see like these documents. And at one point there was a rule that they had to put a sign up that said that there was, you know, radioactive materials buried here, but it had to be understandable in some kind of sign language or whatever, 20,000 years in the future by a single agricultural post-nuclear, you know, post-apocalypse family that farmed in the valley there. They had to know that there was dangerous stuff buried underground. That's where your tax dollars went.
Like all the UFOs at Area 51. What does your wife do?
She used to be a volcanologist. She doesn't do that anymore.
Okay, thank you.
Mark, you make an entire
Usually-
living on the internet on your iPhone.
Yeah. It's true. I'm at work.
Okay.
Trying to get, but this is great. Thank you very much.
Thank you, Bob.
Thanks, Bob.
Happy to do it.
Hey guys, me and Bo just wanted to say something first. Like, so we're both kind of on the hunt for internships. So if you guys know anyone who's doing that for like younger people, just let us know, like through Barbara, or I could give you my information too, or Bo's information.
Sounds good. So Barb, yeah,
So
send it to
what
Barb.
what kind of internships, and are you looking for them right now or for the summer?
Summer. Mostly the summer, but like it wouldn't be bad to find one right now. But I mean, like I'm mostly looking for something like biology related, and he's probably looking for something like electrical engineering
I'm
related.
looking for anything space related.
Or
actually.
that.
Okay.
Well, like I like space stuff too, so I wouldn't mind one of those internships. But yeah.
Find one you can do on Zoom for now.
yes. Yeah. So thanks.
Sure thing. Yeah.
Yeah. Sometimes, so you want it somewhere in the Denver area?
Yeah,
Lockheed
definitely.
Martin might be good.
Lockheed Martin, yeah, I've heard they do.
Yeah, that would be good.
That would be good.
He also lives in Texas, so like.
Well, I can move. I can move around. I can afford to move around.
Summer. Okay. Sounds good. Really. So, and Zach, your biology, what did you say that was?
Biochemistry.
Biochemistry. Okay. And then electrical engineering?
Yep.
Okay. Great.
Both really
And,
hard.
Yeah,
I mean, it's not hard right now. But we are in our like second month of freshman year, so like.
Oh, yeah. So what courses are you taking this semester?
So I'm basically taking nature and human values.
It's
And
like
it's
an ethics class.
It's like an ethics class for like all engineers. And then I'm taking economics, chemistry, calculus. That's pretty much all. Like I didn't really like, I'm gonna do more classes next semester, but I wanted to feel like what the base load was before I like loaded up on stuff.
I did the opposite.
Yeah, he just loaded up on everything.
Yeah, I loaded up on what I could. I'm mostly taking the same class as he is, but I'm also taking design class, and I've got you're in chem, of course, but I'm not taking econ this semester. But mostly I've got the same class as you do. I just did add a couple more.
Barb, I don't know what it is about your microphone, but.
Okay. What kind of design?
It's the basic principles of design. So like problem solving. So we're given a problem and then we lay it out and then we make the report and then we do the prototyping. So right now we're in the prototyping phase. And my team is working on a solution for how can we mitigate the spread of COVID-19 in the travel industry. So we're all coming up with different ideas for that right now. I think I've got a good one. I think.
Yeah. Can you tell us?
Chemistry test tomorrow.
Yeah, we've got a chemistry exam tomorrow.
Oh, yeah. Okay.
Yeah, it's our first one, so.
Oh,
Yeah.
okay. We better let you go.
Well,
I mean, we've been studying all day, so it's like
this is
we're
our
like on
break.
like 6 hours of studying today already. So like,
yeah, I think we're okay. I think we're okay.
and it's like I did high school chemistry, and basically the first unit of chemistry here is basically just like all of that. So I mean, it's not like too hard. It's basically just like
the same. It's
Yeah.
a review.
Yeah, it's basically a review for us. Other than like memorizing all these like
Polyatomic ions and
acids and stuff.
I'm
So,
so
yeah.
glad you're back here, Zach, and so good to meet you both.
It's good to meet you too. I'm glad to be
Yeah.
here.
Yeah, and someday we'll have telescopes and we can all get together, too. Hey, you have a telescope, Bo, right?
Yes, I do. That is actually one of the most valuable things I brought from home to here. So
She wanted to hear about that. She sent me an email. Like, so just tell her what it is. Like,
yeah, it's a Celestron telescope. It's kind of a cheap telescope, but it's like a 127 millimeter aperture. So it does the job. It's not the best thing, but it gets it done. I've taken some decent photos. I would like to get a new one soon, but that's gonna have to wait.
Yeah, sometimes we hear of ones that are for sale, or sometimes, people give us ones too.
Oh my, that would be nice. But no, over the pandemic, I kind of picked it up and it's become like a major hobby for me now. So
That's great. Good.
I really do love it.
The smoke's been kind of getting in our way, though.
Yeah, like, no, but did I tell you I looked at the moon like when it was like orange? It was really weird.
Really?
Yeah, it was kind of weird. I didn't get a good picture of it though. Not enough time.
But anyone else have anything to share? Or I don't want to push this off here. And some of us usually stay later. John A. and Mark and some other people, but you're, whatever you want to do. And let's see. So yeah, we'll try to send you an email about that UFO panel, if we can do that. And we'll try to give you a couple weeks notice. And then, as some people were saying, we'll try to send you that link the day of or day before again too. So it's easy to find, because I know I search for those sometimes. Anyone else have anything?
Well, how is your husband doing on getting our search for or extraterrestrial life or whatever that panel is going to be going?
Do you want to say a few words about that, Leonard?
Well, I've got 3 or 4 candidates that seem to be interested in doing a panel. And unfortunately, one of the people got jailed. So I had to circumnavigate that person. But I actually just finished a new article today on UAPs and UFOs. So I found another pretty good source on doing a scientific look at UFOs. So bottom line is, we're not going to do
what UAPs are.
Unidentified aerial phenomenon. There's a whole other offshoot of UFO research now. These are the Navy pilots that took images of something that nobody can quite figure out. But the Navy actually started a task force to look at this issue. And so it's becoming more real, and it's very interesting, intriguing, but I think we're far removed from them being piloted by extraterrestrials, but who knows? I think we're waiting for Barb to finish our taxes, and then the UFO meeting will happen.
Where will you submit that article that you just wrote?
It'll be out, I don't know when. This is a space.com story, so sometimes it takes weeks, sometimes it's tomorrow, I don't know. I'll let you know. I'll send it. It's pretty, of course, what am I going to say? I think it came out pretty good. A lot of interesting comments from people that are surprisingly very interested in the scientific study of this phenomenon, the UAP phenomenon. And there's some really kind of interesting new twist to that story.
Okay, put up a sticky note to yourself to send it to us when it comes out, please.
I will.
Yeah, that'd be interesting. Can I throw up something on the screen for just a second to thoroughly bore you?
Okay. We'll be the judge of that. That looks good.
That was the night you didn't come, Barb.
Turn on your mute. Turn off the mute.
Okay. Yeah. So this was a couple weeks ago, Judy, with at the end of Axton, or at Axton Ranch, which is one of the areas up here.
It was the
right.
It was the one night that there was no smoke and no moon.
That's beautiful. George tried out his new telescope.
Yeah, I did, but I don't know. I didn't. I didn't look through it. He was busy, I was busy.
Those are beautiful. Great.
Thank you.
Yeah, and you know, if we do, John and Judy, if we do another end of Axton Ranch, that's, you know, up 72 for those of you who don't know our area, up Camp Eden at the very end of the road. And maybe if we do something, as long as we can social distance and wear masks and not touch our faces or whatever, bring our own telescopes or whatever, maybe we could let people know. If you're interested, just email me and we could let you know.
Hey,
And
Bob, quick
I
question. Oh, sorry. Yeah, Bob, quick question.
Yep.
I forgot to ask about electrical discharge. Any effect of that on the phosphine?
There's a
lightning.
Phosphine, yeah, that's one of the things that they looked at. Phosphine apparently is made in lightning. They just said it was at far too low a rate to account for what they observed. But
Yeah.
that's
Sorry, Barb.
probably the one thing that I can dig into. But you know, that I might have some understanding of. But yeah, it does occur in lightning.
But you also
Right.
said that the paper that they cited was maybe the wrong paper, and that another paper suggests there's more lightning on Venus.
Yeah, from the Venus Express spacecraft, Chris Russell and the magnetometer group detected not flashes but signals that they thought were due to lightning, and they figured that it was, I don't know, 20% of the flash rate on Earth, which is like a lot.
Yeah.
But if all the lightning on Earth still is enough to make it, then then you have to rule it out.
Well, you said there was phosphines on Jupiter and Saturn. Where do they come from?
They're made at the high temperature and pressure deeper in the interior.
So it's just a
not
strictly
super deep,
chemical reaction.
It's the chemical reaction, because of the amount of energy that it takes. It's a big energy barrier to putting this compound together, and at those temperatures and pressures, there's enough energy,
Which Venus does not have.
That's what is claimed.
Also, there's a lot of hydrogen in Jupiter, so the raw materials are there.
Yeah, it's probably already anoxic down there, right?
Yeah.
Yeah, Venus is actually kind of oxidizing too, so I don't know how that works.
John, Bob, I have a question for anyone who thinks they have more biology knowledge than I do. Is it considered that phosphine is a way for these anaerobes to get rid of excess phosphorus in their cells?
How do you like that?
That was a
There you go.
good question.
I don't think life has a problem with excess phosphorus.
Yeah.
I mean, phosphorus is so important to DNA. So,
Yeah.
And to enzymes and stuff. As a matter of fact, I was involved in a paper some years ago about sort of trying to figure out what how much elements and
Wanna study
energy
after
were
this?
available
We'll study
for
together. Yeah, I need to
life
try
on
that.
Mars. And the thing that came up short was phosphorus. There wasn't enough phosphorus on Mars, just in what we looked at. So yeah, I don't think there's a problem with too much phosphorus, but again, I don't understand the first thing about why bacteria actually make phosphine. So I think once we read some overview article on that, we'd be able to have more of a conversation.
Yeah.
I'm just curious. So did we have any Planeteer protections, or did we sterilize any of the probes that already passed through Venus's atmosphere? Or did we just send them on their way?
Yeah, they've never been sterilized. The first two big probes to Mars, the Viking landers, were sterilized.
Nice.
But
Oh, that's good.
Because me and
I
him were
hope
talking,
so.
like, maybe they already got destroyed.
but they haven't done it since then.
Yeah.
Oh, that's great.
Well, the surface of Mars is a frozen desert. I mean,
True.
nothing can live at the surface.
True.
There could be stuff underground.
Well, yeah,
Could be.
but we don't know yet.
Well, and it's also highly irradiated, so you
That
got
too.
that going for you.
Pretty much there goes. There that goes.
He wants to go to Mars.
Oh. It is a very far-fetched idea.
We have a future astronaut over here.
It's a very far-fetched idea.
They're gonna need a lot of astronauts in 10 years, 20 years.
So
Hey.
Bob, can we recreate all the conditions to do a chamber test?
Yeah, that exists. There's a
Oh.
big facility at NASA Glenn that has mostly focused on looking at chemical weathering. Like, they put a Venus atmosphere in there and pressurize it, and they put little rock samples in there and watch them change composition, or take them out and measure the composition. I don't know that anybody's tried to do atmosphere experiments or try to look. Presumably now somebody's going to want to do something with phosphine in it, so they're going to have a whole new level of containment probably. But yeah, that facility exists.
Okay.
You're muted.
John, you have to go, John Williams. So you're making me host? No? I thought you said something.
You still can't hear you.
Oh, you can't hear me? No, I said, I see you have to go, so you're going to make me host, right?
I still have homework to do.
Yeah. Hey, I do like your shirt. That's great.
Hey, it glows in the dark.
Oh, I forgot to wear my Venus shirt. Rats. I'll have to wear.
Oh, come on. There's a dress code for this thing,
Right. I've got a shirt that the Venus people made for me that says "Back to Venus" in like the Back to the Future font. So
Cool.
there you have it. That would have been the whole thing. See you, John. Thanks.
Thank you so much.
Thank you, John.
Say, Bob, why isn't there more mixing, or apparently not, between the predominantly CO2 lower atmosphere and the upper atmosphere where this phosphine is?
It's fully mixed. I mean, we don't know how deep the phosphine goes because you can't see in the millimeter wave, that deep. I mean, it might go 10 kilometers down or something, maybe a kilometer. I don't know what the penetration depth is. But my understanding is the atmosphere is very well mixed. But it can't be too well mixed, or the bugs would get flushed down to the surface.
How much water vapor is in this region that we're talking about?
This is a big problem.
Yeah.
I don't know what the ppms are, but it's not like there's a convenient raindrop for a bug to go hang out in. If it could do that in a sulfur dioxide droplet, then that's okay. But yeah, I forgot what the amount of water is. It's finite. It's not zero.
Yeah, that would have to be a pretty tough bug to do that.
Well, I mean, this is so Leonard was mentioned earlier about the Mars meteorite, which I would say he says there's still an argument only because he's a journalist and there's always two sides of the story. But the thing that really galvanized was not just the missions, but the whole field of astrobiology, right, which has been huge in the last 20 years. Yeah, understanding, I forgot what I was going to say.
That's okay. I mean, part of what it reminds me of is that we started out by making assumptions a long time ago that life would be just like us or what's on Earth. And now we're changing as we get more data to say, well, or maybe not so much. Maybe it's this, maybe it's that. And of course, Sagan kind of talked about that, for the upper atmosphere of Jupiter and places like that. But it's basically showing how we've had to change our assumptions about life as well.
Yes, yes, and that reminded me, Carolyn, that yeah, the mantra, as well, if life can live there, it will live there.
Mm.
So yeah, I mean, I think to get back to the question with the clouds, is that all the bugs that didn't know how to survive over the last billion years or whatever are dead, and the ones that are there have evolved to be able to survive in that niche. I think it's an incredibly nasty niche, but it's their niche if they're real.
So Bob, how are you going to remain objective about going to Venus? I mean, the
Why do I
Mars.
have to be objective about it?
Well, you don't have to be, but I mean, we scientists sort of try to be, and the Mars rock back in the mid 1990s really spurred a whole huge change in what the NASA planetary program then did, even though the science kind of collapsed pretty quickly about life in that Martian rock. And so this phosphine thing on Venus is the first thing that's happened for Venus in a long, long time. And you've been very interested in sending missions to Venus.
I feel, well, first of all, this is a partisan business, right? I mean, it's people, because it's destination based, because there are places you have to go to that take enormous resources to get there, people form camps,
Right.
around their different objects. And, right now the moon is my object, right? I got an instrument going to the moon. That's what I'm working on. I'm working with, people how to find deep water on Mars. If that ever works out, I'll do that. So, yeah, I mean, Venus I feel that the way I presented tonight, I showed what the caveats were. And the first thing I put was figure this out. I'm not going to encourage NASA to pick Da Vinci. But if the opportunity comes around the next couple of years to propose a Venus mission that might be able to make some measurements, of which this would be one, then I would endorse that.
Mm-hmm.
So yeah, I'm jack of all trades, master of none.
Well, yeah, well, I agree with that. I'm all in favor of going to Venus, but I'm in favor of going to Enceladus and Europa.
Okay, let me use the Bob Dole quote, which may not be true. I think they did it on Saturday Night Live. It's my turn.
Yeah, actually, I think it's the turn of the extremophile lovers to get into this now.
Well, somebody, I don't know if you know who Paul Byrne is. He's a younger planetary scientist. He's at North Carolina. He's Irish, so he has this amazingly attractive accent. So he's just a joy to listen to when he gives a talk. But he was quoted as saying, boy, if this phosphine thing turns out for real and there's life on Venus, then forget all this Mars crap.
Well, aren't the bugs that live deep in the ocean in the Marianas Trench and the 600-degree water, and are those I know they don't have sunlight. Are those oxygen lacking anaerobes
I don't think
also?
anything lives in 600-degree water. But
And that's where it gets its energy.
So the water, the hydrothermal water could be 600 degrees. It's under pressure to be down there. But by where the actual bugs are living is some distance from that, where the heat is diffused and the temperature is not quite as high.
Quite that high.
But aren't those sulfur eating?
Yeah.
Yeah.
Yeah, I mean, so that's part of the whole study of what are the most extreme environments on the Earth, and how do we learn from them about where microbes could have colonized elsewhere. So that's why you want to go to Europa. There's someplace you didn't mention, Clark, because if there's an ocean underneath there, then you could just forget about bugs and just look for whales.
At least penguins.
Right.
European penguins. That's cool. I like that. We need an artist to draw those.
Well, the penguin would have to come out of the water. I mean, the whale, actually the whale would too.
Both mammals.
Plesiosaurs.
Oh, penguins are birds. Sorry. Plesiosaurs.
That's what I'm looking for. Thank you. See, that's why I didn't study dinosaurs. I couldn't pronounce them.
I'm gonna run, you guys. See everybody in the next talk. Bye.
And Laura, I just wanted to say, Laura Danley, thank you so much for the talk you gave. I think most of our group, was on when you gave your talk, and really enjoyed that so much. Thank you so much.
Thanks. And I just wanted to say about Europa, since you guys were talking about going there, with every passing month, it seems we get more and more confirmation that there in fact is a plume coming out of Europa, and in fact it is water, and it probably is coming from at least subsurface reservoir, whether all the way in the deep ocean. So I want someone to send a CubeSat to go get us some and bring it back.
How you do it with a CubeSat?
What?
How you do it with a CubeSat?
Well, it would have to, everything's getting smaller these days. It's just that it'd be fast to accelerate the thing. That's all. I want it to happen in my lifetime. I don't want to wait 9 years.
Well, why wouldn't Europa Clipper do this?
I don't think it's.
About that, they all don't.
Others may know better, but I think it doesn't have instrumentation. Well, certainly it doesn't have a sample return aspect.
It has a mass spectrometer on it.
It does. I'm getting at bringing us some Europa water back.
You want it to come back?
Yeah. So I want it to fly through, scoop up, open up, and then come home.
So they have Fiji water now in the store. If you want to have Europa water.
Yeah.
Bottled European water.
Next big industry.
$1 a bottle. Yeah, next big industry, bottled European water.
Exactly.
And Barb, I corresponded privately with John on this, and I sent him the file. I should have sent it a month ago of the talk, so he should have it now. We can't hear you, Barb.
That's right. He didn't post that. He was waiting for you for that, right? Your talk.
I'm sorry.
Yeah. No, that's okay. I was bawling him out. Why don't you have Laura's talk up there? I thought he had it. Really. And I just want to say to Zach and Bo, Laura is the chief curator at Griffith Observatory in Los Angeles. Have either of you been there before?
I have not. No.
Yeah, if you go to LA, and I'm sure she'd be glad to meet up with you. But it's an amazing place and beautiful place too. Lots of good stuff there. Yeah.
I mean, I think me and my sister are actually going to LA to visit my uncle this summer, so that might be a possibility.
Oh, lucky you.
That'd be okay, Laura. Yeah, that'd be okay, Laura. Right?
If I'm here and not in Colorado, I'm thinking I might want to go a wandering for a while.
Oh, really? Oh,
Yeah.
really?
Yeah.
Take a sabbatical?
Yeah, something like that. Get a camper van.
Woohoo!
That'd be nice.
Yeah. So I thought I might come to Colorado for the winter. I still have a place up in the mountains that's been rented for all these years since I left in 2004. And
Breckenridge, right?
In Frisco.
Frisco, yeah.
Wouldn't it be great to be in Colorado for a couple? I mean, I haven't been in the observatory in 6 months, so I could be anywhere right now.
Well, we have plenty of smoke here now, so I don't know.
But there's smoke bad in California too, though.
Yeah.
It's much better. It was bad there for a while. You saw the orange skies from San Francisco. It was so weird. Looked like Blade Runner.
That's one way to put it. Kind of creepy. Did you see that picture?
No. But my mom sent me like a whole bunch of pictures like from the front yard. It's like pure orange in Oregon. Oh my god, that's kind of
ouch.
See if I can
One thing, Zach and Bo, there's a fellow or a professor there Angel Aboud Madrid that you might not have discovered yet. And I think I sent you information on him, Zach, but I'll send that again. And he's in charge of the space resources. He does a conference.
Did he
What?
respond?
He used to do
I
it.
emailed him the other day, but like 2 weeks ago, but he never responded.
Well, email him again and I'll tell him that you did too. We're very close friends with him. We go to his Space Resources Conference there when you can. They, of course, put it off this year. But yeah, that's great. Good. Yeah, get in touch with him. He's great.
I'll have to send him another email because I was like the other day I had like this burst of inspiration like, hey, let's email this guy because he's like in charge of the Space Resources program here. And it's like, so I took that.
Good.
But yeah, I'll
Okay.
definitely do that again.
Yeah, I'll write to him too. He knows Leonard and I real well. So, yeah, definitely
Awesome.
connect up with him.
Awesome.
Good. I'm glad we made that connection.
Yeah, definitely.
The vaccine should be here by 2021, supposedly, so we'd finally have an in-person meeting by the end of the year, maybe.
Yeah.
We'll be there at
I'm glad
Colorado
you're
School
taking
of
the
Mines.
long view.
Yeah.
I mean, I might want to wait a few months after it comes out just in case.
Make sure it works. Yeah. No bootleg vaccine.
All right, folks, I think I'm about talked out.
Hey, thanks
Thank
so
you all
much,
for
Bob.
attending the
Bye,
Thank you, Bob.
Bye.
Great
Yeah,
talk.
thanks,
later.
Bob.
Thank
See
you,
you next
Bob.
time.
Thanks, Bob.
Thank you. And if you have a second, I thought I'd show my favorite picture from the orange San Francisco skies.
Oh yeah, you need to
Yes.
see this, dude. It's weird.
Well, this one,
Can you do that?
this one is has a particular.
This is fine.
That's definitely my favorite one. So we've got All Space this Friday, which is one of the reasons I'm in and out and kind of have been. Let me stop my share. So we're covering, of course, the atmospheric conditions in California, and that one's going to be in there as a lead into a little discussion about climate.
That's good.
That's for this Friday?
Yeah, we haven't talked climate all year because a pandemic was enough, but this is bad, and we had our 121-degree day here in Los Angeles, which was insane. And then within days, we've got a certain denizen of the White House saying something about, oh, it's going to cool off. It's like, yeah, winter's coming, so it will
It's gonna
cool
get
off,
colder.
but it's not. It's
The Earth tilts in a way where it gets colder. Very surprising.
Yes.
It's not like it's all going to magically disappear. I don't mean to be political, but I feel like this is such an urgent thing, and if we continue to ignore science, we're really dooming ourselves. And so I'm going to go there this Friday, as nervous as that makes me.
I'll
We talk
send
about
out this.
that.
I'll
Go
send
ahead.
out this email and we'll put a link to that in, so that people could call in if they, because anybody can, right?
Yeah, we
All
actually
space
stream
considered.
from Zoom to YouTube, and then people can exchange in the comments. But I have deliberately decided to leave part 2 pretty empty, so that we could have more discussion and find some way to do that. And I'm not quite exactly sure how that would be, but we'll figure that out.
It will get political.
It will. And I'm a city employee and I'm paid for by tax dollars. So I have to, I want to keep it's about science. It's got to stay about science. And I will talk about the importance of science because we see it every day, and, ignore it at your peril. But
Well,
I won't talk candidates. I won't talk platforms. We're not talking about the election. We will say, as we always do, vote, but that's just a city. I'm just a civil servant saying vote. I'm not saying who to vote for. But I think anyone who would tune into All Space Considered would probably vote anyway, I suspect.
Do you know if 2030 is still the irreversible date? Like, is that still are we still 10 years away, or did they lengthen it a little bit because we're not doing anything?
You know, honestly, and I didn't even think to see if I can do something this, but you know, we did have a nice little drop in emissions there in those first few months after COVID struck, but it's gone back to normal. So I don't think that forestalled anything. I think it's still probably, you know, there are many people who feel that is a tipping point.
Well, I actually wrote an essay recently about how we're like decreasing our coal consumption in the U.S. recently. So I mean, but we're switching it to natural gas, which really isn't that much better.
No.
So like, I mean, it's a slightly cleaner, but it's still, you know, fossil fuel. So.
And we'll talk forest management and, you know, all sorts of other aspects about the fires and everything. So.
I just
Laura, go ahead, John.
I was just going to throw in that this 2030 date. I think if you can remove carbon out of the atmosphere, it doesn't matter so much, but those are very immature technologies right now.
Yeah. Yeah. I don't see us doing it. Well, now here we go political again. It would have to be an Apollo program style, all out blitz effort to get there by the end of the decade. It's not impossible. We've done it before and we walked on the moon, so that's cool.
Just cut down the Tongass and seal our doom.
Laura, regarding the forest management section, isn't California a pretty rigorous fuels management state? I know Colorado isn't, but California's got a pretty rigorous program, don't they?
One of the things that was surprising to learn is that the state of California, let me see if I can get this number right. Oh shoot, I have a slide on it. What I do remember is that our forests are 58% federal lands, followed by private non-industrial lands, followed by private industrial lands, so logging and forestry. And then the last little bits are state-owned and municipally owned, you know, or local government, so counties, cities, and state. But it's, you know, very, very, very small fraction. So I don't think that California, we're dominated by the federal, and there's another correspondent covering this, and I'll throw to him. But I have seen, we talked about it a bit, and he was telling me that, you know, between the Park Service, the Forest Service, and the Department of Agriculture, you know, the sort of history of how they've changed their policies to include, I mean, it was a backfire that saved Mount Wilson. I don't know if you guys follow that.
Yeah.
But I mean,
We're following it.
So in fact, tomorrow I'm talking to Sam Hale, who's, you know, George Ellery Hale's grandson, and I'm going to do a quick Zoom interview with him and record it just to get his personal take on it. But that night when he told me, I spoke to him on Friday, he told me that the flames came within 20 feet of the monastery. The monastery is where all the scientists would stay. It has a library and a kitchen. Einstein stayed there when he hung out with Hubble. So there's this marvelous history of, you know, of that whole confrontation of the expanding universe between Einstein and Hubble that took place at Mount Wilson in the monastery where they were staying, and there are pictures from it and stuff. So very historic building. And Sam told me that the flames leapt onto the roof. They lit the roof, but didn't ignite the monastery. But the wall of flames came to 20 feet of the monastery, which is on the southern end of the property. So it was very, I mean, it was so close, so close.
Jeez,
terrifying.
Yeah, you can't get much closer.
I know. It's 20 feet from here to my street. So it would be as if the flame had this wall of flames right at my street, right out the window.
Laura, you know, of course, Rob Staley and Lori Paul.
Yeah.
Right? Because we were all together in LA. Just put it that way.
In Einstein's room.
What?
In
Einstein
Einstein
room. Yeah. But they are in Altadena, near Pasadena, and the fire is now 5 miles from their house. They're right on the edge of, civilization, sort of. They've got the vegetation outside their house. So we've been checking with, where the fire is every day, with that.
Yeah.
But they had to evacuate at one point and then they let them back in. I'm not sure where they are now, but, for us in Coal Creek Canyon, from where most of us are, it's about 10 miles down to 93, and 5 miles, I can't even imagine staying here if it were that close.
Yeah.
Does anyone
You
know
gotta go,
Richard
John?
Berry?
Okay. Yeah.
Yeah, me and Bo got to go too.
Gotta go. Yeah. Okay.
Does anyone know Richard Berry?
What?
Richard Berry?
No, I don't know. No.
No.
He was that editor of Astronomy magazine for a long time. And he moved to Oregon and his house burned down just, 3 weeks ago.
Oh.
I know a friend who lost like her whole entire town, like it basically burned down. So
Oregon,
scary.
right?
It's just
Yeah,
gonna get worse.
Yikes.
Oh, yikes is right. Thank goodness October's coming.
well, everyone, have a good night. Yeah.
Hi, nice to meet you.
Thank you. Nice to meet you guys too.
Right.
Bye.
See you, Zach and Bo.
Yeah, email me.
Bye.
So, bye guys. Bye.
So, Laura, are the fires contributing to the heat? Like you said, it was 120 in LA?
No, the heat just came, and actually that is also, Patrick will cover that. So he's covering the heat wave. I don't know much about the weather confluence of, pressure systems and so forth that led to that, but oh my God, it was unbelievable. And it lasted for days in the hundreds. My personal temperature outside my door was 114. But it was the record in the LA proper was 121 in Woodland Hills. And even at the beach, it was 100 and something. And the beach always has it's always 15 degrees cooler than everybody. So it was unprecedented heat.
Was that with the Santa Ana wind? Was it coming from the east or?
I don't recall there being Santa Anas because that has a particular feel to it. I don't know how to say that if you've ever been in California for the Santa Anas, that it's this, this devil wind. It really feels like it's just straight out of hell that is blowing and has kind of it's an ethereal, otherworldly feeling when you're really getting those Santa Anas. I kind of thrilled to it because it's so nature has such power to it, even though it's often deadly, often accompanies fires. But I don't believe we had Santa Anas because I don't remember that. But then I kind of stayed inside like everybody. I did go out at our peak on that 114. So I got to go out and garden and just feel it. I want to get so hot, see how hot it can feel. That was kind of fun, but it was bad.
How's your garden doing through that?
It's been struggling. It's okay. It's fine. I'm near the end of my summer vegetable garden anyway. So.
Yeah, it's been in the hundreds here too.
Where are you, Kelly?
Southeastern Colorado.
Yeah. Very
Dry.
Yeah. I've seen you guys have had tough times. The plains, really got it more than once this year.
Yes, they did. Yes, I agree. But that's life. Good night, guys.
Okay, thanks for being here.
Ciao.
I'm gonna have to bail too. My dog is calling.
Good
Nice
night.
to see you guys.
My bed is calling. I've got a book to read.
I've got work to do. But I did want to also just apologize. I think I failed to mute properly. Was I making all kinds of noise in the beginning of your show? because Alana was here and I wanted to watch it with her, but then anyway, so I was trying to capture it and so I could come back and see the first part that I missed, and I did not succeed. And then I realized the mute button was not unmuted, and I've been talking like, wait, we were.
Didn't hear a thing, I don't think.
It didn't trigger anything.
No.
Thank goodness. I was appalled at myself. I thought I just talked through the first, like it took, anyway. Yay, thank you.
Also, one thing, John is usually the whatever you call it, moderator, whatever, but he can mute you. If you're bad, he'll just mute you. He, you know.
I hope he did that then.
Yeah. Or he might have. Yeah, I was trying to mute myself when Leonard was speaking downstairs because it sounded like it was an echo there. But, so you can hear me right now, can't you?
Yes.
Is it? Yeah.
Especially if you make sure you lean forward and talk
But
loud.
I'm 73 now. I don't want to lean forward. I want to be back here.
There's got to be a way to adjust
So
it.
bad. What?
There's got to be a way to adjust that microphone.
Yeah, well, I thought I did before we started, but I'll have to check it afterwards and see what happened. But yeah, that was great to have everybody on here. And Bob Grimm was emailing John and I. He said, "I didn't see the email about my talk. Is anybody going to be there?" I sent it to him twice. Said, "Hey, this went out Thursday. You didn't see it." But yeah, I thought that was a great talk, and it'd be great if we could get Clark Chapman to talk about Mercury, if we're going to do planets, because he's very much involved with the Mercury.
Oh, you faded away, Barb.
Mercury Messenger mission. He's worked on that, counting craters and on that whole, but he knows a lot about Mercury, so it'd be good to have that as a talk.
I thought Clark was giving Bob a little bit of crap about his enthusiasm for the phosphine observation, whereas I thought Bob was actually being fairly skeptical. Anybody else?
Yeah.
Yeah, I thought so too. Well, Bob, Clark was, see, Bob Grimm usually gives everyone else a bad time when they're speakers, so, maybe Clark was getting back at him.
He had a smile on his face at least.
Yeah.
Yeah, I think there's some friendly joking going on, which is great.
So Clark and Y and I were on, they do this Brat Fest. They've done it for 40 years. It's with the Southwest Research Institute, a number of other groups of people who work together. And they had, it's gather.com, I think. Have you ever tried this? It's almost like a video game, but so you have an avatar and you can see where all the people are. And you do this little walking thing with your little avatar down to, talk to these people at a table or the bar, or, they're in a group, and then you see their pictures. And God, it was great fun. It was really neat. We just went on it I did for, 10 minutes or so, but it was, it's kind of like Zoom, but you have all these people all over the place because some people were in other cities than Boulder. Yeah, it was fun. I think it's gather.com. So we could try that sometime for the fun of it. The technology actually worked. There was somebody who was a host who made sure knew how it worked. It was kind of fun.
Things are changing, and I think it's totally exciting. There are a lot of things that are changing that are not exciting in the least. But one of my favorite things about this insane year has been to see the incredibly creative ways in which people have adapted and made it work and come up with creative new ways to do things. And, We're such great creatures when we get out of our way, our own way.
Well, yeah, it is funny. One of the things we've watched a couple of episodes of Cedric the Entertainer. This guy does it's sort of a stay-at-home America's Funniest Home Videos, and he's got some just hilarious things on there. People doing dances and the kids at homeschooling kind of thing, and just a lot of neat things. I think it's Ced's or Cedric's funniest stay-at-home videos or something like that. The other thing we watched the last couple nights was the new Challenger accident movie, and I think it was in 2 or 3 episodes on Netflix, and it was sad, you know.
Yeah.
NASA wanted that to come out right now, you know, because it was all about thiokol and, you know, the problems, and they interviewed a lot of interviews with the families of the people who died. So yeah, but you know, it was kind of great to see it and honor them one more time, you know.
Yeah. It feels like ancient history.
Yeah.
Has anybody watched Away?
Yes. Oh, we like that. Yeah.
Okay. I'm only on episode, I don't want to spoil, I'm only on episode 3, so.
Say anything.
Or do I want to say anything that would wreck it for anyone else, but.
Have you 3 seen that, Away?
No.
Is that on Netflix? Is it Netflix?
Netflix, yeah. So if you have a membership, it's free.
What's the basic concept there?
First trip to Mars, first humans going to Mars. With Hillary Swank and some other people.
Yeah, a lot of personal issues, but I think the thing from it that I don't believe is believable, I don't think any country would pick people who had so many issues, you know, because one guy, yeah, well, one guy, his parents died and somebody else raised him. Another one, his brother died when he was young. You know, they're just a whole bunch of complicated, well, not complicated, but, you know, tragic things in these people's lives. And I don't think you should send anyone on a mission like that.
And right from the outset, you see that they are competitive with one another, they're not a team, and they would never have sent them. That's my one thing too.
So how far are you into it?
I think I can say they've just launched. Okay. I mean, if it's a show about a mission to Mars, one might imagine there might be a launch. So it's in episode 3. So all the stuff with the family and stuff has happened.
So, and you know, 2 years of training, you think they would have worked out those issues, but I would say, you know, without saying too much, that doesn't remain through the whole thing, you know.
It's better drama than science.
Yeah, I'd say so. But it's, yeah, you know, I think we're all really critical of anybody who tries to make a space movie. They never get it right.
Yeah.
Completely. But right. Yeah, it's really, I think both Leonard and I thought it was great. You know, what we just finished watching totally, well, there is a little space in it, The Crown, about Queen Elizabeth.
Yes, and there is space in it.
I think there's another season, but, you know, we're not into paying for it. So we're waiting for it to come on Netflix for free. But, you know, just binge watching these things. Yeah, it really interesting. They do have the Apollo astronaut, you know, the Aldrin Armstrong and
Collins.
Michael Collins. I'm sorry, Collins. You know, they come to visit the Queen, but it's, you know, I mean, I grew up, my mom was Canadian and she really respected the Queen and all that. And, you know, we see her on TV and she's 94 now, you know, and it takes it from when she was like 25 on, you know, well, let's see, I guess at this point it must be the 60s, you know, when the last one we saw. But fascinating, I thought, you know, I didn't know any, and Princess Margaret, her sister, oh my God. And Helen Bonham, what's her name, is playing
Helena
her.
Bonham Carter.
Carter,
Yeah. Oh, speaking of which, also on Netflix, so if you have Netflix is free, is this thing called, I think it's called Enola Holmes. And
Yeah, what do you think of that?
I adored it. And I was surprised because usually I'm very critical.
Yeah.
It's a family trait. We criticize, critique everything. But I mean, within the first 1 minute, I was completely pulled in.
What's it about?
And Enola Holmes is Sherlock Holmes's younger sister.
Oh, right. Yeah, because if you haven't seen the Sherlock Holmes one with Cumberbatch, is that his name? Or?
I've
Oh,
seen
man.
one. I think I've seen 2 episodes of that. But this is a movie. It's not a show. It's a movie. It's 2 hours, and it has the young woman that played that very interesting character on Stranger Things. If you watch Stranger Things, I've forgotten the name of the character, but I think her name is like 5 or something. But she, oh my golly, she just took on the screen right away. You just right away pulled in. And
I want to
suffice to say, a mystery ensues. It's a fun mystery. She's great, and Henry Cavill plays her brother. But it's really about her, not about him, not Sherlock. It's about her.
Is it based on truth? Loosely, maybe.
I have no idea.
The other one I want to watch is The Social Dilemma. I watched the trailer on that, and
probably rotten.
Judy, I was going to say there's a man sneaking up behind you. But yeah, The Social Dilemma, that's, about how we're really screwed, with what it's so interviews with a whole bunch of people who work for Google, Twitter, Facebook, who are just, saying we're way too, that they know all about us, it makes me really careful about what I put in an email. We should be a little careful on Zoom too. I don't know if they have enough Google people to watch all our Zoom.
I think it's too late.
What?
I think it's too late.
I don't post much on Facebook. Yes, you can advertise to me about the moon. I'm fine with that. Or space.
I did just create my own Twitter account. Here I've had this career for how many decades, and I have never been on any social media. But about a week and a half ago, I created a Laura Danley Twitter account, largely because although I tweet all the time, as All Space Considered, I wanted to have a personal platform. So if I had an opinion about something, I could have it and not be representing the city of Los Angeles. But I haven't tweeted anything yet. But I did create it. It's like, oh, now they're going to know everything about me.
Facebook is my platform for sharing pictures with my family and my photo groups, and that's about all I do, except for the occasional political comment.
But are you public, or is it just within your group?
Just my friends. Yeah. That's enough, because I've got friends that are so far that way, and I've got friends that are so far that way. I'm an independent.
You get these people who go, yeah, I want to be your friend. And, Leonard's got a lot of people on Facebook because he only really uses it to post, things, space, his articles, and then his own website, leonarddavid.com. He writes a lot of articles. And the good thing that's come out of that is that space.com will pay him $75 for some of those articles. Of course, he's done all the research, some of them are pretty small, but he's done all the photo search and everything on them. So, you know, it's easy money for them, you know,
Yeah,
and it's
that's
nice for him. It's, but yeah, so, you know, I get these people and I'm going, I don't know who that is. That's nice. They're friends with Leonard. I'm not taking, I don't need any more friends, you know, on Facebook. And
I just wanted to comment, Judy, about the far right and far left bit, because I think given that there's such a, you know, the Lincoln Project has had, and I was having this thought, the Lincoln Project just put out a just searing, scorching ad about Lindsey Graham. And, you know, he's a nice central Republican and would have been their buddy had they not become just, you know, we got to get Trump out. And so anybody who enables Trump has got to go too. This is, do you guys know the Lincoln Project? Do you know what I'm talking about?
Vaguely, yeah.
Yeah, so it's a bunch of Republicans who defected. And I have been really intrigued about the possibility of a central, a party up in the middle. Because,
nice.
yeah, because I don't, you know, even if the thing that united us was a common, and I'm going to just speak, and I'm sorry if I'm offending anyone, but I think that there's a common recognition that what's happening is indecent and crosses a line. So at least on this side of this line, we're all in agreement, and that's a start.
Yes.
You know, so if we could start there, that there are some lines that should not be crossed, and, you know, democracy is one, and, you know, decency another, and a few, you know, whatever. Then then could we start there and unify? I think you've heard me say, Barb, that for the longest time, I thought the ticket it might have been an interesting ticket to have Joe Biden and Mitt Romney. Yes. Looking like Joe, since he's pretty far right for a Democrat, and Mitt has become the voice of, you know, the left part of the Republican, or, you know, the at least anti-Trump part of the Republican Party, although perhaps not now, that, you know, here we have essentially two grandpas. Don't worry, everyone. We're the unity party. It's not about right and left. It's about country first. We're going to work together. We're going to find a place in the middle, and we're going to make this okay. And those of you who are here and those of you over here, you know, there's a room for you under this tent, but we're not going to, we can't do this face-off thing anymore because we're ripping the country apart.
Right, exactly. You have a Catholic and a Mormon.
With that.
What were you going to say, John?
I was just going to say, yeah, if the two sides were this far apart instead of
that
far apart.
Exactly.
And then we can get back to arguing reasonable things that we ought to argue in a healthy way.
Yeah.
Because it's so off the charts. And I really do think, I really think our country's in danger. I really do right now. I am terrified.
Yeah, I'm more worried about the economic part of it too. I think people are just, you know, I can't even believe Biden wants to run. You know, I'm sure Hillary's going, God, I'm glad that wasn't on my watch, you know, and I'm not sure she could have done that much better. Probably, you know, but, you know, what a situation, you know. I think people, I mean, I guess all of us are kind of okay, you know. I mean, you know, Leonard lost one of his jobs. It wasn't, you know, with NASA headquarters. It wasn't related to the coronavirus, but, you know, just cutbacks. And we've gotten other work and we're okay. But, you know, I mean, just you think about the impact on the restaurants and, you know, just everywhere. I don't think we're going to come out of this. I'm sorry, you know, but I'm amazed that the people in the news reporting and everything seems to think things are sort of okay, whether Trump or not, you know, just with this virus, you know. And we've been inside now 6 months. Gone out 10 times, I think, for gas and drive the car around. That's about it.
I went wild and went to a restaurant last night, my first time.
Wow.
It was outdoor seating, and our table was at least 12 feet away from another. And the waitress came. She looked like she was about to intubate us. She was like head to toe, completely covered.
The
The
plastic.
shield and the gloves and the mask under the shield and everything. She was completely decked out.
Restaurant was that? Is that one of the ones we've been to with you?
Possibly, if you know LA, Tam O'Shanter, which is the one that Walt Disney always had dinner at.
Oh, really?
Yes.
Yeah, I don't think
Just
I've been there.
a couple of blocks from Walt Disney's home. And it's a, old-fashioned roast beef, what's that called? Prime rib and creamed corn and creamed spinach. It's like sort of straight out of 1938. And I had just absolutely wonderful time. I actually saw some friends in person. We were all at least 6 feet apart from each other and
Great.
outside. And I was like, okay, I'm going to do this, So we'll see if I get sick in the next 10 days. But
Yeah, let us know.
it's the first time I've seen anyone.
Wow.
And
Really?
that mom came today, so we were in the backyard, but socially distanced. So I'm starting to maybe tiptoe my way out, but I have seen no one and been inside no buildings other than my home in 6 months.
Really? So you've really done it too?
Really done it.
I mean, it's bad because I knew our UPS guy before and FedEx, but the UPS guy, we were on a hugging basis. We gave him the first copy of Leonard's Mars book and the first copy of Moonrush, because he delivered it. So we opened it up and gave him one, signed. But so every time he comes, I'm out on the upper deck, so I'm about 15 feet away and talking to him for as long as he'll talk. So, lately he's been going, I gotta go, but he likes talking too.
It's
But
like
yeah.
my gardeners. So the only people I see is like, how long does it take to blow the leaves around and water stuff? People.
Yeah, really. And one thing we're doing, I may have mentioned this last time, but Laura, you weren't on then. But Bill Maher came up with, or he talked about how we should, all you people are ordering Amazon stuff that you don't really need. Well, I'm ordering stuff we need, but he said, don't do that for, the time of the election, to just reduce the amount of mail so that these ballots get through. And that's what I'm trying to do. I'm ordering all our vitamins so I have them for about 2 weeks after the election and before I have to order again, and other things. But I got to tell you that the best thing I bought was, we had a little foam soap dispenser by our kitchen sink to wash our hands with. I got one from Simple Mind is the company, and it's automatic. You just put your hand under it, and it was about $60, but it's wonderful, and we love it.
Because that's kind of annoying, frankly, and you're like trying to do the pump thing with your wrist,
Yeah, yeah. No, this is great. I can send you the link to what it is, and I got it direct from the company, not through. I don't think Amazon even had it, but really good customer service. I read all the reviews, dozens of them, and everyone said the customer service, if they had any issue, they just sent it back and they sent them a new one or fixed it. So it's kind of neat.
I think Jeff Bezos has been getting a lot richer during this.
Oh my God.
We've been contributing.
Yeah. I just got this thing you see on the internet, this flashlight with the glass breaking and the seatbelt cut thing.
Yes.
Flasher.
Oh, really? Yeah.
Powered and everything. I thought, yeah, that's going to be a good thing.
If you ever drive again.
Oh, but
It will cut your
I
seat.
think I am going to do a little car camping in the fourth week of October. And,
Where?
To Mammoth, and mainly, I have a lifelong desire to see the bristlecone pines.
You have a what?
To see the bristlecone pines.
Pine, yeah, I've been there. My dad wrote an article on it when I was a kid.
Really?
Yeah.
There's
I'll see
something
if I-
about them. They're magical. I want to be in their presence for a while. I want to hike up and spend a day with them.
Yes.
And so I have some friends who are going to go like stay in a hotel in Mammoth. And I thought, ooh, this would be a good sort of test if I car camped, still, caravaned with them. So I'm not alone, but then stayed out of my van, out of my Highlander. And then they would go back. They're just going for the weekend, and then I might stay a day or two and go on over to the bristlecone pines from Mammoth. So that's my big adventure. I'm gonna give it a try because yikes! I
bet it'd be fantastic.
Until next fall.
What?
I can't have what I've done for the last 6 months be for the next 12 months. I can't.
Yeah, I know. Yeah. Yeah, we're thinking about driving around looking at the leaves changing. They're really changing now.
Yeah.
In our yard too, but that may be as far as we go. But yeah, that's great. We've spent time in Mammoth Lakes before, stayed at a hotel there. And then the place that I went every year for 40 years was Rock Creek, just north of Bishop, between Bishop and Mammoth Lakes. And there is a fire in the lower Rock Creek area I saw. I didn't check it today, but hopefully they'll get it out.
Well,
really
that's true. This
scary.
whole trip is pending the fire situation because just over the Sierras onto the west side, but up by Mammoth Lakes is where that huge fire was. That had a lot of, I can't remember now what the big news was because it was one of the first fires before Bobcat and all the others,
Yeah.
And
that one's out? Or is that still
I don't
burning?
think so. But the satellite images showed the smoke coming. I mean, it was just huge smoke coming out of that particular fire, which was right by, not too far from Yosemite.
Yeah. Is that on the west side though?
Yeah.
Yeah, okay.
So Mammoth Lakes was protected because that's on the east.
Because of the mountains. Yeah.
Yeah. Oh, beautiful.
Oh, yeah. I hadn't seen
That's where we were Friday.
Oh, really? Where is that?
Just a minute. I got to take this phone call. That was up at Rainbow Lakes.
Okay, great. Beautiful. Thanks for sharing that.
Yeah.
I got to go. I got a call I got to take.
Okay.
See ya.
See you, Judy.
Bye.
Take care.
Bye. I'm hanging on to the very last because I just wanted to say hi, and I missed so much of his talk. I invited Alana